Hello, and a warm welcome to everyone on behalf of the Bayer Foundation and the organizing team here from Berlin, where we have gathered in a small group in a room. My name is Tatjana Gus, and I'm the Associate Director of the Science Programs of the Bayer Foundation. It's my pleasure to kick off this symposium on One Health, which has been organized by a group of very engaged Bayer Science Fellows in collaboration with Bayer Foundation in only 4 months and is broadcasted from different Bayer sites in Germany and the US. Thank you also to the technical team and the support teams at the different sites for making this event possible. In addition, I would like to extend my gratitude to all the speakers for their efforts and time to share their research, and I'm eagerly anticipating the talks. So maybe looking at the agenda, Lisa Lockwood from Bayer Crop Science will start the symposium with an overview talk on One Health, followed by Stefan Ludwig from University of Münster, Germany, addressing One Health's challenges. Morven McLean from Washington University, St. Louis, will show us the impacts of gene editing on food security and public health. And with Franco Falcone from University of Gießen, yes, right, Germany, we will explore cysticercosis as example for the One Health principle. Then we will have a break, which will take place at around 4:30 p.m. German time, 9:30 CST and 10:30 EST. And after this break, we will learn from Sebastian Günther, University of Greifswald, Germany, how we can tackle urinary tract infections in a One Health perspective. Mark Mannery from Washington University will then guide us through the future of processed food and the project Peanut Butter. And Emise Söke from Consumer Health will provide us insights into the self-care equity. And the symposium will be concluded by a panel discussion with our esteemed colleagues Lisa Lockwood and Kiliana Susad-Wojcik from Bayer Pharmaceuticals, giving us an overview about Bayer's initiatives regarding One Health. That's the agenda for today. And before we dive and start the symposium, I would like to introduce you to the work of the Bayer Foundation. Just a short overview. So our vision is to advance science and social innovation in alignment with Bayer's vision to enable a world with health for all and hunger for none. We work here at the different intersection, health, environment, and nutrition, and we actually have 2 pillars we are focusing on. On one side, it's social innovation in low and middle income countries, and on the other side, it's advancing science. And here that's the part where I'm responsible for and where you can also see on the next slide what we are doing right now. So here the science part is looking into advancing breakthrough science by honoring outstanding scientists with awards for their research achievements. Early career scientists, but also established scientists are being awarded for their research in different fields like biology, chemistry, and also data science and medicine. On the other side, we also try to foster exchange by, on one side, offering fellowships for young professionals like master and PhD students in different fields. And we just right now have, for the first time this year, established a climate and health fellowship. So if you have master or PhD students or know some of them or medical science students, please feel free to forward this information. And also we foster exchange by symposia on cutting edge science and lectures. And we have a lecture series in place, and also here the symposia is part of this lecture series called Boundary-Breaking Science Lecture. And yeah, it's a real pleasure, as mentioned already, to be part of this symposium today. And last but not least, we have a second pillar, which is also very important for us. It's increasing equity in science. And here we have We focus on two focus topics. One side is building scientific capacity in Africa in collaboration with the Alexander von Humboldt Foundation by providing fellowships for researchers, for African researchers, to really extend their knowledge in their research fields. And on the other side, fostering gender equality is also a major focus area for us. And here we have a collaboration where we support female scientists to establish their leadership skills and with that establish their career in academia and in science. If you want to learn more about us, feel free to scan the QR code on the right-hand side, or we can also later on provide more details on our website. So please feel free to reach out to me. My name is Tatjana Gust, as mentioned, and with that, I'm very, very pleased to start the symposium and hand over to my beloved colleague Lisa Lockwood in the US to start us with the first presentation. Hi, Lisa, are you there?
I sure am. Can you hear me? Can you hear me, Tatjana?
Yes.
Okay, excellent.
I do.
All right. So today we're going to talk about a really interesting topic. People forget that pesticides are critical for public health. And I think this talk, I hope that we'll be able to get you a little bit into that. So I'm Liza Lockwood. I'm the medical affairs lead for the crop science division at Bayer. I'm an emergency physician and a medical toxicologist. And a lot of people say, what is an emergency doctor doing in ag? Well, we have a little bit of an emergency because of misunderstandings about ag. And I will contend that agriculture is one of the foundations of civilization. We've got 10,000 years of experience with organic farming, and there's nothing wrong with organic farming. It just doesn't reliably feed 10 billion people by the end of the century. So hopefully this talk will give you a little window into how there's so much connected in One Health. One Health is really the balance between human, animal, and planetary health, and we all have the same goal of trying to make it as successful as possible. So from plague and pestilence to pesticides, pharmaceuticals, and public health is the name of this talk. So let's go to the next slide. So back in 1800, life expectancy was abysmally low at 30. By 1900, the average person in the United States lived to the ripe old age of 45. 45% of our population farmed at the time, with a significant number of them being subsistence farmers. Fast forward to 2000, and we had gained an unprecedented 35-plus years in life expectancy, with less than 2% of our population farming. That part of the farming population not only feeds the whole 330 million of us, but exports close to 25% of what they make. So they are really critical for global food security. 5 public health advances of the 20th century made this possible. Next slide, please. Water sanitation decreased the incidence of transmission of fecal microbes like cholera and typhoid. Fluoridation prevented tooth decay, which led to improved oral hygiene and decreased the incidence of things like rheumatic fever, which is a heart problem. Next slide. Food security led to an unprecedented abundance of healthy fruits and vegetables that were previously unavailable to the larger population. In the West, these 2% are able to feed so many people with this. Next slide. Antibiotics offered a cure to previously deadly strep and staph infections. Next slide. And vaccines eradicated smallpox and came close to eliminating polio and yellow fever. Next slide. Vector control became the cornerstone of preventing outbreaks of infectious diseases of the Middle Ages, like the plague and typhus. So let's maybe talk a little bit about the plagues of the Middle Ages. So rats and fleas transmit pathogens between animals and people. Yersinia pestis, which is a gram-negative coccobacillus, it's a bacterial infection, profoundly shaped the history of the world. When a flea feeds on an infected rat, the bacteria multiply in its pharynx, in its throat, rendering it incapable of swallowing. The hungry flea then lands on a person and has a feeding frenzy because it can't swallow. It repeatedly regurgitates plague bacteria into its host. The subsequent infections lead to bubonic, septicemic, and pneumonic plague. Next slide. After inoculation, plague travels, go back one slide, sorry. After inoculation, plague travels through the lymphatics, the little channels that go to your lymph nodes, and they rapidly multiply in the lymph nodes, resulting in massive lymphadenopathy. These are swellings that are called buboes. When the bacteria enter the bloodstream, either through the thoracic duct in the chest or by direct inoculation into the microcirculation, septicemic plague, triggering septic shock. Infected white blood cells called macrophages travel to the lung, resulting in plague pneumonia, which is spread by droplets when patients begin coughing. Pneumonic plague has 100% mortality if not treated within 24 hours by antibiotics. Next slide. Patients with plague develop acral necrosis, that's hands and feet, of necrosis of the hands and feet, resulted from microthrombi in the circulation, so you get little clots that cut off the circulation. The blackening of the skin is how the disease got the name Black Death. Next slide. Plague was one of the most notorious public health disasters ever recorded, and it turns out Ukraine played a star role in the outbreak. Next slide. In the mid-1340s, the Tartars laid siege to the Crimean port city of Kaffa, now known as Feodosia in modern-day Ukraine. Plague broke out in the ranks of the soldiers, and in one of the first documented incidences of biologic warfare, they launched infectious dead bodies over the walls of Kaffa, sparking a disease that flew through the city. According to accounts of the epidemic, quote, almost everyone who had been in the East fell victim to a sudden death after contracting this pestilential disease, as if struck by a lethal arrow which raised a tumor on their bodies. The scale of the mortality and the form it took persuaded those who lived, weeping and lamenting through the bitter events of 1346 to 1348, that the last judgment had come, unquote. Nothing stopped the spread. Go ahead, next slide, please. Plague doctors examined patients in medieval hazmat suits, the original PPE. Let's see if I can go. There we go. The disease ravaged Europe, wiping out approximately 50 million of the population, which had a knock-on effect of reducing the amount of land that was able to be cultivated because of shortage of laborers. This led to widespread food insecurity. Up until the 20th century, there were limited options for controlling global pandemics of the bubonic plague. The predecessor to the World Health Organization was established in Paris as the Office International d'Hygiène Publique, specifically tasked with developing protocols to address plague outbreaks. These protocols were rudimentary and involved isolation and incineration. Like with COVID, strict implementation of these protocols resulted in significant resentment from the communities affected. Relief came with the 20th century scientific breakthroughs that led to the development of new chemistries which kept the plague at bay. This included the discovery of antibiotics, insecticides, and rodenticides. And as you can see from this map, plague is still endemic to many parts of the world. And the reason why there aren't more pandemics that require isolation is because of pest control. So how did we make these discoveries? Well, by digging back and leaning on Mother Nature. Around 400 BC, the Persians discovered that the simple daisy had a superpower that changed the world forever. They discovered that this flower could kill insects. Remember, plants can't run away from you, so they defend themselves by making their own natural pesticides. This common daisy, Chrysanthemum cineifolium, produces pyrethrin, a naturally occurring insecticide that modulates sodium channels in the nerves of insects, and it doesn't bother our sodium channels, so the insects get paralyzed and we don't. Worldwide militaries paid close attention to the insecticidal properties of plants because one of the leading causes of death in the military turns out to be insect-borne illness rather than war wounds. For example, when Napoleon invaded Russia in 1812, he went in with over 400,000 men, and by the end of the Russian campaign, he came limping out with less than 4,000. The conventional wisdom was that they all died because they were overwhelmed by the Russian winter. They invaded in June. About 20 years ago, during an archaeologic excavation, a mass grave of Napoleon's soldiers was uncovered. And when they exhumed the bodies and examined them, they realized that the soldiers had died of typhus, a louse-borne disease, completely preventable with modern insecticides. We have taken pyrethrins and made them even better by using the principles of organic chemistry to make them more stable in light and less allergenic. Pyrethroids combine Mother Nature's backbone with human ingenuity to create chemistries that prevent malaria, treat lice, and control the expansion of invasive insect species like the Aedes mosquito, which carries dengue, West Nile, and yellow fever. This expansion is being quickly aided with global warming. Now imagine this. If you could find a gene in one of those plants that confers pest resistance and transfer that gene into a crop, you wouldn't need insecticides. But that science is not very popular. More on that later. Fleas are only part of the problem. What about rats? Well, that leads us to another One Health type story. In the early 1920s, Wisconsin farmers were faced with a puzzling problem. Their cattle started dying of massive hemorrhages. In February of 1933, a farmer by the name of Ed Carlson got fed up with his cattle dying without an explanation, loaded a dead cow onto his truck along with a bucket of blood that wouldn't coagulate, and brought them to the Wisconsin Alumni Research Foundation, where they discovered that a naturally occurring coumarin in sweet clover is converted by moldy hay into a compound called dicumarol. Dicumarol happens to decrease prothrombin times in the blood, and that causes anticoagulation. Warfarin was launched as a rodenticide in 1948. It turns out that rats are very particular about their feeding habits and warn other rats away from eating things that make them sick. Fortunately, warfarin does not make rats feel sick, so they eat it, and 3 days later, they bump their heads, have little head bleeds, and die. So who else needs blood thinners? It turns out that people with atrial fibrillation, which is an irregular beating of the heart, greatly reduce their chance of stroke with anticoagulation. In the past, it was also thought that anticoagulation could prevent ischemic heart disease, so heart attacks. After our U.S. President Dwight Eisenhower had a myocardial infarction, he was put on warfarin. He was put on rat poison to prevent the worsening of his ischemic heart disease. Warfarin is still a first-line medication for the prevention of stroke, even though it started out as a rodenticide. Fortunately for us, I'm going on to I went the wrong way. Fortunately for us, vitamin D, the same vitamin D that you make in your skin when the sunshine hits your skin, is a rodenticide. That's right, your very own bodies make a pesticide. The same vitamin D that people are selling at very extraordinarily high cost to treat COVID. Vitamin D causes hypercalcemia, high calcium levels in rats, and has now supplanted warfarin as a first-line rodenticide. So how do we prevent the plague from causing another pandemic? All it takes is a little vitamin D and some synthetic chrysanthemum spray, which are both pesticides and critical for public health. The scientific advances of the 20th century were absolutely unprecedented. Again, in 1900, 45% of the population farmed, and the average life expectancy was 45. By 2000, 2% of the population farmed, and we gained an unprecedented 35-year in life expectancy, despite 2 world wars and several mass famines. This was because of the 5 scientific advances in the 20th century that brought us this public health: food security, water sanitation, vaccinations, antibiotics, and vector control. Unfortunately, we're at the crossroads of superstition and science in agriculture and in medicine. Believe it or not, there's common ground, and that common ground is pursuit of the truth. Science is a tool that can shine light on reality, regardless of ideology. So I have a challenge for you. Be a beacon of light in the face of the dark. Tell the truth. This is our Garden of Eden, and our job is to keep it alive for our children. Thank you very much. Does anybody have any questions? Let me see. Can you give a One Health example that affects crops? Yeah. So one of the really interesting stories of the Middle Ages is there were large outbreaks of a disease called ergotism. So insects would transmit a fungal infection from weeds into food crops like rye and barley and wheat and things like that. And when the insects would transmit this fungal infection, there'd be mass outbreaks of something called ergotism. And it was such a horrible disease that it caused 40,000 people to die at a time in France in the Middle Ages. They would have seizures and hallucinations, and they'd have vasoconstriction of their blood vessels. So unlike plague, because you get blackening of the hands and feet because of the circulation being caught up by little microthrombi, you'd get vasoconstriction and no blood to your peripheral circulation. So you'd have animals and people were affected by this, and lots of people died. Well, it turns out that ergot has actually some very interesting pharmaceutical properties, and it turns out to be life-saving in postpartum hemorrhage. And so in the early 1930s, they discovered the alkaloid in the ergot, which was good for preventing postpartum bleeding. It makes the uterus contract. And postpartum bleeding is one of the leading causes of death in maternal death in the developing world. And so they isolated ergonovine and then wound up making a synthetic version. Everybody thinks synthetics are bad things, but made a synthetic version. And now it's the first line treatment for preventing even sometimes postpartum bleeding. So it turns out that this crop infection wound up having life-saving properties. It also had a natural alkaloid called lysergic acid, which was the predecessor for LSD. So it wound up launching the whole hippie movement globally. So yes, you can get terrible disease, you can get pharmaceutical quality treatments, and you can get recreational drugs all out of the same plant, or not plant, fungus. So let's see, Liza, human epidemics are often transmitted by animals, but how is the connection to the ecosystem, including agriculture? So once again, yes, you get zoonotic transmission of diseases, and some of those are pretty significant. You think of rabies, you think of, West Nile and some of the infectious diseases that we talked about. Ebola is another one that's thought to have originated in some of the rainforests in sub-Saharan Africa. If you destroy an ecosystem, you often increase the contact between humans, populations, and other species, and then you can get outbreaks of things like Zika and things like that. So it's very important to have a balanced relationship between urban and suburban environments and nature to try to minimize that kind of contact going forward. So there are all sorts of creative ideas for how to manage this kind of thing. Okay, I think that's it for questions. So maybe we can move on to the next speaker. Thank you.
Okay, so welcome here in the room. Welcome to all people outside. My name is Stefan Ludwig. I'm the head of the Institute of Virology of the University of Münster. At the same time, I'm also coordinator of the head office of the national research platform One Health, which has been recently funded to support the One Health community in Germany. So what I want to do with you today is first describe you a little bit where we come from, One Health platform, how we develop, what our aims are. And I will give you some examples of the science of the projects we support. At the end, I will also go into my own research, namely a project which now has led to clinical trial studies on SARS-CoV-2, which has actually started as a basic science project within the One Health platform or the zoonosis platform. Next slide, please. Can I? Oh, okay. So where do we come from? It all started out in 2005, and you may all remember we had the bird flu, the H5N1 bird flu, arriving in Germany at the coastline of the Baltic Sea. And it was an initiative of 3 ministries, actually, the Ministry of Research and Education, the Ministry of Health, and the Ministry of Agriculture and Consumer Care, who came together and formed like an agreement on zoonotic diseases, recognizing that these zoonotic viruses and bacteria got an increasing problem for human health, and they want to do something against it and fund actually research consortia on different zoonotic pathogens. In 2009, then, the idea came up that all these, it was 11 consortia on different zoonotic diseases, they all worked a little bit side by side and not like together in a common approach as a zoonosis community. And so the zoonosis platform actually was created in 2009, again, by the initiative of these 3 ministries. And this platform actually should serve as a communication and service platform for the different zoonosis consortia existing at that time, and also the other research community in Germany that works on zoonotic diseases. This research agreement was renewed by addition of a new ministry, the Ministry of Defense, then leading to the establishment of yet other research networks on zoonotic diseases. And in 2022, then, this research agreement was expanded. 2 other ministries, the Ministry of Environment and the Ministry of International Collaborations, were included here. And we as a zoonosis platform applied for driving these One Health platform then. And we got the grant, and in 12/23, we started the One Health platform initiative. And to just give you an impression here, I think we are the only research consortium that is funded and supported by 6 different federal ministries in Germany, which is kind of a safety thing, because if one steps out, the others are still there, but it can also be a mess. Because they have to be consent in many ways. But we managed to get along. Okay, next slide. Can I switch? Yeah, okay. In our One Health platform, we actually adhere to the One Health definition of the One Health high-level expert panel. This is a panel of scientists from the quadripartite, the WHO, the FAO, the OAI, and the UNEP, actually united in that quadripartite organization and formed that expert panel. And so we already heard this today, that One Health is a collective unifying approach that should balance the health of people, animals, and ecosystem in a recognition that everything is connected. And so you cannot only think human health and do not care about environment or animal health without caring for zoonotic transmissions of diseases. Next slide. And you have seen this picture probably many times. Down here, we have the One Health issue that we want to have healthy ecosystem, healthy animals, and healthy humans in a nicely connected balance. And we have to integrate there many different sectors and disciplines, and also the society on local, national, and international level. And actually, we as the One Health platform see us a little bit there on the top. So what we do, we connect people, we help them to communicate, we initiate collaboration, and we coordinate like the One Health community in Germany, and hopefully in the future also abroad. Next slide. So the aims are actually to strengthen the One Health approach in research by connecting researchers and also initiating research consortia. There's also the aim of transfer between research and the practice. Of course, public outreach and raising public and political awareness is one of the goals here. And also now more to network with international One Health initiatives. Since we came with our community from the zoonosis field, in the moment we are working to expand the zoonosis community into the environmental, climate change, and biodiversity communities, and connect them into our group here, which worked out really well already since we started in December 23. Next slide. So structure-wise, we're actually a highly democratic organization. It's all based on our members. We have around 1,300 members, which makes a quite big community already. And they're actually coming from all the different disciplines and different fields here. And these members every year on our big symposium, they vote for the scientific advisory board, and we take care that all the disciplines are well balanced there in these advisory boards. There are elected members and also appointed members. And the scientific advisory board is actually working together strongly with our head office. And we have a decentralized head office structure. Münster is the coordination office, but we also have an office at the Friedrich Löffler Institute and the Helmholtz Institute for One Health, both situated in Greifswald, actually. And the decisions are taken in the scientific advisory board, sometimes with help of ad hoc experts from the outside, and then executed from the head office. Next slide. So what are our activities? So we do not do research ourselves, but we try to facilitate others to do that. Others could do their research. One major pillar here of our activities is our yearly One Health Symposium. Next slide. Which will take place in October 13 to 15 this year again. But we also have workshops which we could apply for. If you have an idea on different One Health topics, you could apply for a workshop, 15,000 euros to gather people and to discuss different issues on One Health. Next slide. So to project funding, I will come in a second. What we are very, very interested in is to support young researchers, because we feel that if you catch them when they are very young, you have the biggest development into the future for people not living in their pillars of sciences, but feeling to be part of a One Health community. So we have a lot of different events. We have a One Health certificate, which they can get and put in their CV. We have training grants and so on. And this also streaks out into international networking by providing travel grants to our events and so on. And of course, we also do public relation events. To the project funding, we have two pillars of project funding, actually. And the project funding is not very massive. So we have small pilot projects and small collaborative projects with 2 to 3 different groups from different disciplines. The idea is here that we fund projects that are high risk, that are new, that bring in new ideas into the research activities, and then bring these people to the step where they can apply for further funding with bigger initiatives like the ministries or the German Research Foundation and so on. And to give you some examples here, next slide. And the next. One which is already quite old, that was actually one of the first zoonosis research consortia called FBI Zoo, foodborne infections. It was a big group that were looking on different foodborne zoonotic infections of humans. The speaker actually was Lothar Wieler in that days. Afterwards, he became the president of the Robert Koch Institute. And one of the highlights they did really in that consortium, and that was a big success, they actually managed to get the rapid test for the EHEC pathogen, which then actually stopped the EHEC outbreak in 2011. And without the activity of this consortium, this would not have been possible. Next slide. The next. It's doubled. Rather a recent addition to our activities. That's an ongoing project by Stefanie Becker from the THO in Hanover. And they actually want to learn about what role insect viruses play in the susceptibility of mosquitoes to pesticides, which actually might be a quite interesting topic here. And so how insect viruses can be combined with optimized insecticide management to improve especially the vector control. Next slide. And another project which is recently ongoing is by Cornelia Silagi on the survey of mosquito fauna as part of the revetting of moors, because you have the One Health could also be quite conflicting, because for nature and for CO2 reduction, it would be good to rewetten moors and swamps. But on the other hand, you would also create host areas and areas for the hosts, vector hosts for pathogens. So quite also an interesting topic here. Next slide. So, and with that slide, I want to go over into that what we are doing. That actually is a project which was based on the activity of the so-called Flu Research Net. This was also one of these first of 11 EMBF-funded projects on zoonotic diseases. And we combined here veterinary medicine, pathogenesis of influenza viruses and the clinical infectiology to answer questions about the molecular signatures that determine the jump from a pathogen from the animals to humans, and here especially on influenza viruses. And from that, actually activities arose, next slide, where we asked the question to get better drugs for these zoonotic diseases, because especially when these pathogens like influenza or SARS-CoV-2, when they jump from an animal species to humans, in most of the cases, this leads to a highly hyperinflammatory infection because you do not have any defense of your immune system. And although we have drugs against these pathogens, they are not very, very effective. And we have a big problem here. So next slide. And the reason for that, next slide, please. The reason for that is that these hyperinflammatory infections, they start with a virus infection, but during their development, if you would not recover and would end up in a very severe infection, like here on the right side, you have an overshooting host inflammatory response phase. And if you look at this picture, it's clear that the direct acting antiviral would not help a highly severely diseased person. So we need other drugs here. Next slide. So the problem here is that direct-acting antiviral drugs are only effective in the early stages, on the left side of the last slide, which is so there, and not in the hyperinflammation phase. So we need new strategies here that take into account the full course of the disease, not only the virus phase, but also the later stages. And the approach we followed here, starting out in this Flu Research Net consortium with 3 different partners, is to target host cell signaling pathways that are needed for virus replication, but at the same time would also interfere with the overshooting immune response. And the signaling pathway we came up with was, next slide. Now, a little bit of experimental science here was the so-called RAF-MEK-ERK cascade. And actually, this is a highly overloaded slide that was animated before, which doesn't work now. But what it should tell you is that this signaling pathway is composed of kinases, is activated by viruses, influenza viruses, and also SARS-CoV-2. And that this pathway, if it's blocked, the blockade would not only lead to a reduction of virus titers, but also, and that's in the lower left side, would reduce cytokine expression, which would be perfect for these hyperinflammatory responses. Next slide. And because I'm running out of time, next slide, please. Make a wrap up here. What we know about these MEK inhibitors as antiviral agents, they have a broad activity against flu, including all strains we tested. We've unraveled the molecular mode of action. They have a broader time window for treatment, so you can start with treating much later than with direct-acting antivirals. They do not induce resistance. They act in a synergistic with direct-acting antiviral drugs, and they inhibit cytokine expression, but not the actually antiviral interferon response. And we've shown that they act against several different viruses, making them to really a promising broad-spectrum therapeutic approach. Next slide. And this is again showing that we have antiviral activity and pro-inflammatory cytokine responses inhibited. On the basis of our studies, we could start a clinical trial with a startup called Atriva Therapeutics. We could show that the drug is safe and very well tolerated in humans, and then finally did a phase 2b clinical trial called Respire. And next slide. The outcome of that trial is, although we had to stop the trial early because the upcoming Omicron variant, which did not make the people sick enough to be included in our cohort, but we could show that there's a clinical relevant efficacy of our drug in hospitalized patients. And the subgroup analysis also showed that we have both an antiviral and an anti-inflammatory effect. And with that drug, we had a very favorable safety profile. And to sum up, this is actually the clinical proof of concept that you can really target a cellular signaling pathway and treat these hyperinflammatory virus diseases without being harmful for the patient. So next slide shows our contact data, and on the next slide, show you the people involved in the platform activities on our 3 sites here. And with that, since I'm already running late, thank you for your attention and wait for your questions.
Anybody here have questions?
Oh. Hello.
We have a question
locally?
in St. Louis. A couple questions in St. Louis, if they can hear. Can you hear my questions? Yeah, okay. Can these MEK inhibitors be used in autoimmune syndromes as well?
Actually, it's a very good question. And although I do not stress this too much, but I also think that the immune modulatory function of these inhibitors has a lot of implications also for non-pathogenic diseases not induced by pathogens. With autoimmune diseases, it always depends on the length of treatment. I think this is an important point here. If you could treat only certain high or severe disease episodes in short-time treatments, that would be perfect. A long-time treatment over several weeks and months would probably not be working, because then we know it from these MEK inhibitors are also used in oncology, and we know from long-term treatment that they have side effects in the long term, but not in short-term treatments up to 10 days or so.
Do we have time for one more, or do you have one in your room, Olaf?
Hello, any question locally? Yes, please.
Yeah, here you're targeting the hosts, and the question was a bit on safety on the Windows. So what did you do as safety trial before?
Well, there were 2 phase 1 trials on safety and tolerability in humans, which were surprisingly well from the outcome. And the reason for that is probably that the RAF-MEK-ERK signaling pathway is, you have it in tumors, of course, but this is also a pathway which is highly important for growing cells and development. And if you, for example, if you have a perfectly differentiated lung tissue, you wouldn't need a lot of that activity of that pathway anymore. You only get it activated when a virus or an inflammatory challenge comes in, and then you can take away that activity without harming the physiological role of the pathway.
In the chat,
there's one more question.
Do you have any creative? Hello. Do you have any creative solutions for global funding for providing One Health projects? Please, a very short answer. Sorry.
Well, we're working on this. What we did in Germany is to try with our One Health platform to recommend projects to the ministries, and then they decide to which ministry the project would fit best, and then we hope that it will get funded. But this is, of course, not a quite a big approach. We need bigger initiatives for funding, but we have to start somewhere.
Thank you so much. Goes back to the US.
Right. So the next speaker that we have is Dr. Morven McLean, who is the director of the Food and Agricultural Research Mission, which is a new project and a new really exciting program at Washington University School of Public Health. So welcome, and we're glad to have you.
Thank you very much. Can everyone hear me? Good morning, everyone here. Hey, Pam. And good afternoon to our colleagues in Germany. It's a pleasure to be here with you, and many thanks to Dr. Lockwood for inviting me to join you today. So I was given the topic of discussing how gene editing can help contribute to food security and to public health. A pretty expansive topic to try to address in 15 minutes. So we're going to move around a little bit. So when we talk about food security, I think it's really helpful actually to look at the opposite side of that coin. What does it mean to be food insecure? And so what I've chosen to do is really anchor on the definition from FAO, which is when people lack secure access to sufficient amounts of safe and nutritious food. And I really want to emphasize the safe and nutritious part of that for normal growth and development and to have an active and a healthy life. The map you see here on the right-hand side from Our World in Data really shows globally where we have the most concentrated and quite tragic occurrence of food insecurity, particularly in sub-Saharan Africa and South Asia. These are the regions of the world that are most impacted and will continue to be most impacted by climate change, also the regions of the world that have contributed to the least to anthropogenic climate change. And so moderate food security, that's generally associated with the inability to regularly eat that safe, healthy, nutritious diet. And severe food insecurity is more strongly related to insufficient food, so calories, energy. But you can consume a diet of 2,000 or more calories on a daily basis and still be malnourished. And this is the duality now that we see where food insecurity can be manifest in very different ways. And it can be manifest in countries that are both high, medium, and low income. So I'm just going to let you sit with the numbers on the screen a little bit. So food insecurity, a huge issue in low and middle income countries, but also an issue, for example, here in the United States, where the number of food insecure households between 2022 and 2023 increased at a statistically significant level. We're talking over 18 million people in the United States whose households were food insecure at some point. Stunting has huge impacts on the development, not just of children, but cascading through to their growth as adults and their contributions. It affects cognition, it affects things like earning potential later in life. And we have one of the foremost experts on childhood malnutrition in the room with us, and so I'm not going to say any more of that because I'm sure Dr. Manari will be addressing it later. So food insecurity has profound effects on health. And addressing this problem, it's not simply a matter of developing better treatments for diseases that emerge from malnutrition. It's about addressing the full range of commercial, political, environmental, and social forces that actually shape global nutrition. And this has long been a part of the global public health agenda. So some of you may already know that the United Nations proclaimed the last 10 years the Decade of Action on Nutrition. And this was a commitment by UN member states to undertake 10 years of sustained and intentional approach to implementing coherent policies, programs, increasing investments to eliminate malnutrition in all of its forms, leaving no one behind. It's focused on tracking the problem through 6 defined action areas, and national governments activate these into action plans. And one of these action areas is sustainable, resilient food systems for healthy diets. And so these actions reflect something fundamental about why we need public health and about what it takes to actually build a healthier world. So I think of that, that decade of action on nutrition as sort of a global chapeau. And what I'm going to do now actually is bring us down, narrow the scope to really provide a bit of a very short case study on cowpea, which happens to be my favorite crop. So cowpea is an incredibly important, what we refer to as food security crop. It's a staple food crop. It provides protein for more than 200 million people living in sub-Saharan Africa on a daily basis. It's a vital source of protein, particularly as well for those who may not have ready access to animal sources of protein. It also plays an essential role. It provides affordable, nutritious protein but also as a really good source of high quality carbohydrates and micronutrients. It's sometimes referred to as the poor person's meat. It's consumed both in rural communities, peri-urban communities, and urban communities. Cowpea is also an incredibly versatile crop. It's harvested for its grain. It's also used as a vegetable. The leaves are used as fodder, as a livestock feed, and it's used as a cover crop. As a legume, it's able to fix atmospheric nitrogen, which is really important for smallholder farmers who may not have the resources to access exogenous fertilizer. And so it's a really important component of trying to address soil health. It's a short cycle crop. It can mature between 55 and 75 days. And that means that farmers are able to fit it in between some of the main crops that they're pursuing. So, and it's also used in intercropping. It's already, to a certain extent, adapted to the adverse impacts of climate change. So it's heat tolerant, drought tolerant. It's able to be cultivated in soils that are poor, that are degraded. And so again, a really good and very important part when we think about being able to produce nutritious foods under very constrained environmental conditions. So I'm finally going to actually say the words gene editing. So one of the things with cowpea is that the crop itself, the harvesting of cowpea continues to be largely hand harvested. And that's because many of the farmer preferred varieties they're vine-like, they're sprawling, they're just slightly above ground level, which makes them very, very difficult to think about in the context of mechanization using a combine, even a small plot combine. Many of the farmer preferred varieties are indeterminate. So we have asynchronous flowering and asynchronous maturity of the pods. And so that means women and children who are largely, women are the largest cohort, if you will, of cowpea farmers, and women and children will go out to the field multiple times in a serial fashion to be able to harvest those pods. So this is an opportunity that the breeding community is starting to look at. What are the possibilities to actually change the architecture of cowpea to move from the prostate and semi-erect varieties to more erect architecture, to be able to adjust the varieties to really focus on synchronous ripening, determinate growth, and also very importantly, to be able to reduce pod shattering. Pod shattering, if you speak to the farming communities in West Africa, pod shattering doesn't actually rise to the top of a concern because these are being hand harvested. But when you move to mechanization in harvesting, then pod shattering becomes a much more significant constraint. And so work is being done to gene edit cowpea, to change the phenotype of the crop, to be able to build in those criteria that you see on the screen, and to consider whether or not cowpea now can move forward and it can be mechanized. That way there's an opportunity to potentially scale up cowpea production, provide new market opportunities for farmers. And so again, this is just one of the areas that's currently being addressed using gene editing. I don't think my little video there on the right-hand side is working. However, there are challenges, of course. Gene editing is, and you hear this over and over again, and I apologize for using this well-worn maxim, it's a tool in the toolbox, and it's just one tool. So there are also challenges. Cowpea, like a lot of the other staple food crops that don't receive the attention of corn or of soybean in terms of research investments, transformation efficiency is very low in cowpea. That's true of a lot of the staple food crops because simply the research dollars aren't there to really try to optimize it. So it's remained persistently low single digits in terms of transformation efficiency. People who are working, whether it's gene editing or transgenics with cowpea, they're just throwing volume at it, coming out hundreds and thousands of transformants that they're cycling through. but it would be really wonderful if we were able to pay more attention and improve the transformation efficiency of cowpea as well as other crops that have been under-resourced. At this point in time, the two most important constraints to yield are an infield pest, the Maruca pod borer, and a storage pest, the cowpea weevil or brookhead. These contribute to, in routinely, 20 to 40% yield losses under significant insect pressure, up to 100% yield loss. Gene editing is not at a place where it's going to be able to address these constraints. And so that's where genetic engineering continues to be a really important tool in that toolbox that I mentioned. And I think it's important for us to remember, sometimes when I go to meetings, I'm sure you're all very familiar with this as well, there's so much attention being paid to gene editing as if it's somehow going to be able to solve all of the challenges. And it's not. It's going to solve some very important challenges. But I think we have to be really mindful of setting up a dichotomy here where we're saying gene editing is good, transgenesis is not good. And I think that's a vulnerability that we really all need to be very careful about. Gene editing is also being applied to other crops that are really important for food security. These are crops that are foundational to the diets of the majority of the people in the world. So we have cassava, so work with gene editing to try to improve the nutritional profile of cassava. The top middle is teff. This is work that's actually being done at the Donald Danforth Plant Science Center, looking at gene editing of teff to reduce both seed loss as well as reduce the stature because teff lodges at such a high level. With the top right, we have chickpea and then banana, groundnut, and sorghum. In the case of sorghum, using gene editing to try to introduce resistance or tolerance, I should say, to striga, a parasitic weed, again, really important in sub-Saharan Africa and in other tropical and subtropical environments in terms of reducing yield. Some of you may have read the news just a little while ago about 2 new rice varieties. Gene-edited rice varieties released by the Indian Council for Agricultural Research just a few weeks ago. And this is a really, really important first step. And the Indian Council of Agricultural Research, for example, has now put significant resources, over $60 million, into looking at over 37 different crops, both row crops as well as horticultural crops, with all of that emphasis being placed on gene editing. So there's a lot of work in the research environment that is really starting to take off when we look at food security and food security related crops. But in the same way that gene editing is not going to solve all of the problems, we can show up with the best version of a cowpea or the best version of a cassava. And that is not going to be sufficient to actually get that into the hands of farmers, get products to consumers, because the enabling environment is so important as well. And sometimes it's actually, developing the new improved variety is one of the easier things to be able to accomplish. So there are other key determinants that we need to pay attention to: improve seed systems, focusing on advancing policies and regulations so they remain not just parallel with, but ideally ahead of some of the technological innovations. Financing is incredibly important, particularly for the farming community. So looking at access to credit, insurance, the impacts of price supports, both from a positive but also a distorting standpoint, infrastructure, decision support tools, etc. So again, it's the entire package, if you will. We have to look at this holistically and not exclusively focus on using a tool like gene editing to produce a new variety without paying really close attention to what else is happening. And we've seen situations where we think a country's regulatory system, for example, has matured to the point that we don't need to pay attention. I would argue we always have to pay attention, and irrespective of whether it's here in the United States, it's in Europe, it's in India, it's in Kenya. The quote that's on the slide, I actually pulled from the post for this LinkedIn post for this meeting. And what I really wanted to highlight here is what I've outlined in red. So, and we heard Stefan mention this, we heard Liza mention this: the urgent need for cross-disciplinary collaboration and innovation to address complex global health challenges, and not just interdisciplinary, but multi-sectoral as well. And I'm going to actually use that to segue to just very quickly to a couple of things I want to draw your attention to. First of all is the establishment here in St. Louis at Washington University of a new School of Public Health, which was launched in January under the leadership of Dr. Sandra Galea, and is a really exciting proposition for us. The Public Health Plus, you see the third icon over, that's where we're really focusing the intentionality. We're going to be very research intensive in the School of Public Health. And so what we're doing there is we're establishing what I refer to as a network of networks. We're putting together innovation research networks aligned around specific disciplines, but these are not departments or independent units. The idea here is to cross disciplines. The one that I've outlined in red, and I'm at time, so I'm going to be very quick here, is the one that Liza mentioned, and that's the Food and Agriculture Research Mission that I serve as the co-director of. I also serve as the executive director of all of the innovation research networks. So FARM is a really exciting initiative, and it's one of the things that really convinced me to leave Gates Agricultural Innovations and actually join WashU. And that's the fact that the administration at WashU, the Dean of the School of Public Health, has pulled agriculture and food systems transformation into a School of Public Health. This is really unusual, but I think it's actually going to be transformative. And so we're very excited about this. You can see the mission up there on the screen, which I am not going to change. Whoops. And somebody took out my last slide, which helpfully had the URL for the School of Public Health and my email address. But happy to be in touch with any of you. And again, I want to emphasize our focus on interdisciplinary, multi-sectoral research and the opportunities that we may have to work together to be able to address these really intractable problems that we hope to make go away. Thank you.
At Consumer Health, we care for sustainable use of medicinal plants for supplying Bayer's natural products. Do you have any experience in that field?
I have no experience in medicinal plants at all. I did mention, however, a little while, earlier, the Indian Council of Agricultural Research. It actually has dedicated research institutes focused on medicinal plants. And so if somebody's looking for linkages, they might want to look there because, of course, India has a deep history of Ayurvedic medicine, et cetera. So there's a wealth of knowledge there.
Excellent. Another question. Many technological solutions are met with distrust. Do you have any suggestions on how to frame science communication around gene editing so to make sure it doesn't go the way of GMOs?
Yeah, I mean, it's an excellent question. There are no easy answers. I think there are a lot of lessons that hopefully we've taken on from experience working in, for example, genetic engineering, and mistakes that absolutely have been made in not engaging and listening to audiences, listening to consumers. I think it's also really helpful if we're very intentional about ensuring that we're responding to demand-driven consumer both not just issues, but what are those traits? What is it that people really would like to be able to see in their diet? And that we listen to this. And just because we can accomplish the introduction of a novel trait using a specific technique, we have to think really carefully, is that the way to do it? What are the consequences of doing that? What are the knock-on effects? And so again, listening to understanding not just farmer priorities, but really paying attention to consumers, not looking at consumers as a homogeneous group either. And it becomes really challenging. Context is key. It takes resources and time to be able to disaggregate and get the information that can help inform really important choices in what we're pursuing from a research standpoint.
Excellent. Any other questions? Here we go.
Hello. Yeah, one moment, please.
Hi, very interesting talk. I have a question about not the gene editing, but about the general breeding. One of the problems, especially in sub-Sahara, is when you come with hybrid plants. Are these new breeds stable plants that can be sort of given to the community, or are they also dependent on a more complicated logistic of acquiring seeds every year?
Yeah. And so that's where, I mentioned, thank you very much for your question. I mentioned the importance of seed systems. And so it's both crop dependent, it's crop dependent by country dependent, and even within countries, it can be very different. So I think one of the opportunities, and we're seeing more attention being paid to this by groups like the Kenyan Agricultural Research Livestock Organization, by SARI in Ghana, is really building partnerships with the private sector, so small seed companies, to get them engaged earlier on. I think, and one of the challenges has been looking at improving varieties and putting them into a system that may not have matured at the same time as market change. And so again, trying to tie these things together is really important. And so access to improved seed, if I go to my example of cowpea, only 5% of cowpea seed in West Africa is certified. It's a 95% informal system. And so to your question about how do you actually get seed in the hands of farmers, it's really looking at what is the situation now and what would farmers, seed companies, and other actors in the value chain like to see in terms of change. So not just addressing the challenges now, but doing our forecasting. We did a landscape assessment and had discussions with actors, including food companies, and asked a CEO, why are you producing soybean flour and not producing cowpea flour? And the response was, I'd love to have cowpea flour. We have a demand for it, but I cannot get a consistent supply of high quality cowpea month after month. And I can't retool my manufacturing facility for 1 month of cowpea. And so these, I think, are the considerations that we really have to take into account. Seed systems, you'll know better, as better, if not, than I do. Changing seed systems is very, very hard. It's been a really, really difficult problem. It doesn't mean that we don't pay attention to it. We really have to, I actually think, accelerate in that area.
Do we have time? Yeah. So thinking of systems, adding another layer of complexity, how are you looking at the production systems themselves as ways to bring in, improvements in soil health, reduction in greenhouse gas, more sustainable or regenerative practices? How is that rolling in, especially with your work at WashU?
So first, preface this, we're just starting. I think it's going to be through, there's general acknowledgement, Pam, exactly, the importance of what you're talking about. Across the board, whether you're an academic institution, private sector, non-governmental organizations, and other public sector institutions. The opportunity space is about building the partnerships, tapping into those organizations that already have expertise in that area, not trying to replicate it at WashU. So what we're doing at WashU is looking at where can the university provide value addition. We have exceptionally good scientists who are leaders in specific areas. So when you look at the problem definition, okay, where do we fit in, and where do others need to be involved to ensure that we have the continuum? Taking exciting innovations, and what Farm's really focusing on is translating those to impact in the community for the farming community, but also for others in the community, all the way through to the consumer.
Well, thank you very much.
Thank you.
That was very enjoyable. And next up.
Hello.
Go ahead.
Please, Professor Falcone, the stage is yours. Thank you so much.
Thank you very much. Good afternoon, ladies and gentlemen. Good morning in Chesterfield. My name is Franco Falcone. I'm professor in parasitology and zoonotic diseases at the University of Gießen. So I'm going to talk about cysticercosis. I don't recognize the picture. Actually, it's not mine, but that's fine. This is not the most typical project that I would run in my lab, but it's one which really makes it easy to show the intricacies of One Health, all the different dimensions that are playing a role. And I will promise you a twist at the end of the stories. If you can remain engaged right until through the end, there will be a twist which you don't get to hear from scientists very often. So what is cysticercosis? I want to give you a few key facts. So it's one of the 20 so-called neglected tropical diseases listed by WHO. It's classified as a notifiable disease by the World Organization for Animal Health. So that's the animal pendant of the WHO. The disease is caused by Teniosolium, which is a large tapeworm known as the pork tapeworm, but in fact it should be called the human tapeworm because it's us infecting the pigs, not the other way around. It is in many countries the main cause of avoidable epilepsy. So up to 70%, 30% is worldwide the average. In some countries like Nepal, it's 50% of avoidable epilepsy. In a moment, you understand what the link is between the tapeworm in the gut and epilepsy. It's normally diagnosed using imaging technologies, MRI, CT scans, which are not easily available in the countries where this disease is endemic. That's one of the problems. Serology is not very good. Let's put it that way, diplomatically. So the other problem is the economic damage that it causes in low-income countries, because there's lots of so-called backyard pig breeders who rely on this income, to sustain the family, to send the kids to school, etc. And this disease, when it's affecting pigs, it leads to carcass and meat contamination or a lower price. So it has an economic effect on these people. Next slide, please. So you can see 3 foci in the world where the country is endemic. One is South America. The other one is Sub-Saharan Africa. And the third one is South Asia and Southeast Asia. And I've highlighted Uganda because that's where we did a field study in Uganda. I'm going to talk about a little bit later. Next slide, please. So I'm a parasitologist, and there is no parasitology without a life cycle, because everything is in that picture. The interventions, the pathology, the biology, everything is in there, and that's what I tell my students every time. So learn with this life cycle. So what is happening here? So you have a human who's eating pork meat that is infected with the larval stage of the parasite. It's a so-called cysticercus. And if the meat is eaten raw or poorly cooked, the human will become infected. The parasites will grow to a length of several meters. They will be in a small intestine, not causing major problems in the human, but the humans will be shedding eggs. Now, the eggs are infectious for pigs. So when pigs have access to human feces, for example, when feces is used as a fertilizer, they ingest the eggs, and then the larvae hatch from the eggs, enter the tissues of the pig. They can go in any organ. They will go into the meat, into the heart, into the eye, into the brain, everywhere. So that's causing cysticercosis in the pig. So that's pig cysticercosis. Now, if humans ingest eggs of the parasite, the same happens in the humans, what happens in the pig. So the larvae go into the tissue, and they have a high affinity for the CNS. So they end up in the brain or in the eye very often, where they cause neurocysticercosis. And that's a devastating disease. It's causing epilepsy, for example, but also other disorders. So if you ingest eggs, you get cysticercosis. If you eat meat that is undercooked, you get tiniasis, the adult worms. That is not a problem. So the problem is always cysticercosis. Next slide, please. So This on the left is an example of MRI. It's a brain of a patient, and you see these dark areas. These are larval stages of Teniasolium in the brain. And on the right is an example of muscle tissue. You see these rice grain-like lesions. These are calcified cysts, so they have died, and they are stretched because of the length of the muscle, the way that the muscle stretches. So this you can do in humans. Now in pigs, if you want to diagnose the disease in pigs, you don't have these facilities. So next slide, please. This is how it's diagnosed in pigs. You do lingual palpation. So you take the tongue of the pig, you touch it, you can actually see the cysts in the tongue. But it's very, very insensitive. So you only pick up the really heavy infections. So they might still have larvae everywhere, but not in the tongue. So you won't pick those up. So the better approach is you take the pig, you kill it, and you dissect it. Next slide, please. So we're not skilled at this. It took us eight hours to do this, to dissect the killed pig, and we found cysts in the tongue, in the brain, in the heart, and in the muscle. Yeah, so but that is destructive, and it takes the whole day. So that's not a viable way forward. Next slide, please. This is just some lung tissue full of cysts. So you don't understand how they still manage to breathe, because there's going to be inflammation as well. So next slide, please. So what about serology? I told you serology is not very good. So we did a study. We looked at serology published in the last 25 years, so between 2000 and 2025, and looked at sensitivity and specificity. And this is a bubble plot. I don't know whether you're familiar. So the x-axis is the year of publication of the paper, and then on the top graph we have sensitivity as y-axis. And you can see that lots of these circles are very low sensitivity. So overall, sensitivity is a big problem with serology. But also specificity. So the bottom one, which looks slightly better, it looks like it's higher. In reality, it's not, because these are all lab tests. But when you go and use those tests in an endemic country where you have other parasitic infections, then specificity goes down dramatically. So specificity is much worse than suggested on these plots. Next slide, please. So what happens in endemic countries? So I selected 5 problems. 5 main problems. I named them A to E. So A is a problem with animal husbandry. So the pigs are free. They can go wherever they want. They are scavengers, so they eat. So you don't need to feed them. That's the advantage. You don't have to invest in feed, because they will pick up food wherever they get it for most of the year. So you can see here, there's a little pig. There's chicken, there's cats, all sorts of animals, and the pigs are free. They go everywhere, go into the huts, etc. So there's no boundaries. They're not kept in a closed place. Next slide, please. Second problem, I call problem B for bowel. So it's the lack of sanitation, open defecation, latrines are missing. Even where there are toilets, there are sometimes cultural sensitivities. So toilets are for the elderly people, not for the young people, for example. So that means that if someone has Teniasolium in the gut, they will shed eggs, lots of eggs every day. And the next slide is A plus B equals C, and C for cysticercosis, because if you give pigs access to human feces with the eggs of the parasite, that's how the pigs get cysticercosis. You can see this is a latrine. You see the black hole is where feces and urine matter comes out, and it ends there. And if you see in that pit, there's a very happy pig, probably very good against skin parasites. I don't know, I haven't tried. But that's, of course, that's how they get the disease, because they have access to human feces. Next slide, please. Problem D. D for disembowelment. So how the pig is processed? So it's processed in the open. There's no vet looking at this. There's no hygienic conditions. So it's just they're very skilled. They're very quick. So I have a little video I can't show you because of time. In a couple of minutes, the pig is taken apart and processed. But see that murky water? That is water from the local river that's taken for washing. So you don't know what you're bringing in additionally. So that is one of the problems. And then the inner organs, they are just discarded. And so dogs have access to these and they can eat and become infected. Next slide, please. The meat is often not cooked sufficiently. And so if you don't cook enough, you don't kill the larvae. So if you cook thoroughly, they're dead. If you don't, you get infected. So these are the problems that lead to an endemic country being endemic for this. Now, wouldn't it be nice to have good drugs to treat pigs, have good drugs to treat humans, have maybe a vaccination for pigs? That would be great. Well, actually, we have all that. We already have all that. So I'll come to the end later on. So that takes me to the next slides. What are the unmet needs? What is the knowledge gap? Is that we need good serological tests that identify the species that are sensitive enough, but also we need molecular tests, so DNA-based tests. And that's what we wanted to develop. So we had a project in Uganda trying to develop a test based on the use of LAMP. Next slide, please. Sorry, yes, so what we wanted to differentiate is two different Taenia parasites. One which circles between pigs and humans, Taenia solium, and another one called Taenia hydatigena, which circles between pigs and dogs. Now, the one on the right is not dangerous for humans, but it causes problems if you're monitoring the health of the pigs, if you're having control measures. You don't have good serology. You don't know what the pig is infected with. So it makes it difficult to follow the success of your measures. So that's why it would be good to have a molecular technology. Next slide, please. So LAMP is a good technology because it doesn't need equipment. It's fast. In half an hour, you need a reliable result. The primers are very specific, they're very sensitive. And you can have a readout that is available, is good in the field where you don't have equipment. It's a yes, no, positive, negative. So if it's yellow, it's positive. If it's red, it's negative. So this was in collaboration with New England Biolabs who sell these products. Next slide, please. So what we did first, did some experiments in geese, and so we had healthy pig serum, which we spiked with DNA of the two different parasites, Taenia solium, Taenia hydatigena, did serodilutions. You can see when we use the matching species-specific primers, you get yellow, so it's a positive. With the other species, it stays red, so it's very specific. And it's very sensitive. We can pick up 100 picograms of DNA per milliliter. Next slide, please. We then went to Uganda. These were 10 weeks we had, and we analyzed 131 samples. It doesn't sound like a lot, but you do it in the field, then you know how difficult it is. So we had a variety of samples, mainly serum samples, saliva samples, cyst samples, whole blood, plasma, etc. So give you the short result. Next slide. Everything is negative in saliva, in serum, except for the positive controls, they are positive. So the primers are working beautifully, but there is no DNA in those samples, not in saliva, not in serum. So not very successful. Next slide, please. So to conclude, we were not able to detect any Taenia solium DNA with LAMP, although it's very sensitive. This is not due to inhibitory effects. So if we spike samples with DNA, there's no problem detecting them. This is probably because the parasites are not in the blood. So they are in the tissues. So you don't find any DNA in the blood, probably. Now, whether the DNA enrichment step prior to the testing would bring any advantage, we don't know. Anyway, so next slide, and I come to the twist now. So I told you we have good drugs to treat infection in both animals and humans. Oxfendazole for pigs, albendazole, praziquantel for humans. We have one of the best vaccines, T-Sol 18. It's produced in India. It gives you almost 100% protection against infection for pigs. So we have these tools. So we know how the disease is transmitted. I've shown you how it's transmitted. We have all we know. So what else can we as scientists deliver? There is no need for more science. So this is my key message. The next slide. When we think about, next slide, please. About One Health and the three circles, environmental health, human health, animal health, we have to include the fourth circle, which is education, because that's what makes it all work as a whole. So that is my key message. Next slide, please. This is the team. So the one with an arrow is Shahdat, who went to Uganda and did all these experiments. But it's, as usual, it's the teamwork. That's the end of my talk. I would like to thank you for your attention. I'm happy to take any questions. Thank you very much.
Hello, many thanks, Professor Falcone. I'm happy to have already a question from the chat. Do you think that the current trend of calling for free range or cage-free increases the risk for transmitting these diseases? Any thoughts of how to communicate this better?
Well, I'm not an educator. Well, I am an educator, of course, but I guess it's a matter of making people aware of the links and the consequences of your actions, and of course there are reasons why these pigs are kept free, because they don't cost any money, so you don't have to feed them. But for example, you could offer incentives. Say, okay, if you vaccinate your pig, we give you more money for the meat because it's safe, and things like that. So people are trying to do these kind of things, but it's very tough. It's very difficult. Because people are used to the way they've always done things and they don't want to change anything. And that's one of the problems.
Any questions here locally? Yes, Christian, please.
Yeah, thank you. Very interesting. A question related to the DNA-based diagnosis. Do we know that we would need a tissue sample, or is it possible that there are also other matrices that could be sampled, like excrement or so, where we could have a better basis for a eDNA or metabarcoding?
So,
whatever?
Okay, so the excrement would work for humans because they shed eggs, so there is parasitic matter in feces, but it doesn't work for the pig because it's in the tissue. And we've tried CSF fluid, but that's difficult to get. So we've tried urine, it doesn't work, it racks the test because it's pH sensitive. So yeah, saliva is the easiest. It's easy to get saliva from a pig. It takes more courage to take blood from a pig. Saliva is very easy. You have a stick, a little sponge, bit of vinegar, and you give it to the pigs, and they will happily chew on it.
Okay, so you really need the tissue then.
Yes.
We have a question in St. Louis.
Okay. Does this work? Yeah.
Mike?
Yeah, I guess I'm curious about whether or not antigen-based tests are possible. That's sometimes used for other at least helminth infections as well. So, I mean, is there any examples of proteins being? It's not surprising that DNA wouldn't survive unless it's within the egg. But I guess I'm curious about whether or not there's been any work on proteins being secreted by Tenium.
Well, the problem with antigenic tests is the cross-reactivity, because there's very related parasites like Echinococcus who have a very similar biology. And if you look at, for example, one antigen, cyclophilin, between Taenia solium and Echinococcus is 2 amino acids difference in a whole protein. So it's minor differences. So that's why antigenic tests don't work well in endemic countries where you have multiple infections. also different Taenia species infecting the same animal. So that makes it difficult. But we're working on that.
We have 2 questions still here.
Should I start?
Yeah, please.
I would perfectly underline your education issue. That's probably the most important thing which has to be included there. However, so do you really think if you would bring in the knowledge of how the disease spreads, the replication cycle, and what the problems are there, that this would lead to a different behavior of people? There's one of the cultural issues, and on the other hand, also money for bringing in more hygiene issues. So how do you think one could really penetrate these in these environments?
Well, I think it's making sure that people get more money. So, for example, if they vaccinate the pigs, the vaccination is not expensive. If they get premium price for the meat, then that's an incentive, and then it might become a habit. There's also issues of distrust and why should I do this and things like that. So that comes on top of that. It's very tough. I mean, the science has delivered, so now it's really it's education it's negotiating and it's explaining, and that's a really difficult part. I know lots of people who working in for example in Uganda or in Democratic Republic of Congo is a big problem. Also there it's difficult.
Yes, one more short question. Can you please introduce yourself with your name and affiliation, please?
Oh, my name is Justine, and I'm a Bears Foundation Fellow. And I'm based at the University of Witwatersrand, but I'm a visiting researcher in Bremen. So my question again, I think, is similar to the previous question about the system. I mean, we were privileged to come from places where systems work. So I'm assuming we have the beta test, and I mean, we can test these pigs before we even, put them on the market. How do you make, for example, the people supposed to test the meat, make sure the standard is clear, and before, I mean, I feel like there is much more cultural problems that hinder the beautiful science to work in such places. So how do you incorporate in your research these education, like the bottom-up approach, and so that there is some receptibility and also a better system to make sure that what the beautiful science can give the impact that we really need?
I think the science and education needs to work hand in hand. I think that needs to be solved locally, with local people, and making people aware of the issues and offering incentives. But it's really hard, because we have all the solutions, but they're not put together to work. That's the problem. But I don't have a magic formula saying do this and it will work.
Thank you so much. Any questions back in Chesterfield?
I think we've covered them all. Thank you.
So the coffee break is approaching, is it?
Thank you.
We meet again at 5 o'clock Central European Time. Thanks so much.
Do we have one more presenter, Sebastian, before the coffee break, or no? Or is that after the coffee break?
No.
Okay. I guess it's after.
So I think we start. So my name is Sebastian Günther. I'm the chair of pharmaceutical biology at Greifswald University. And in the next few minutes, I want to give you an overview about antibiotic residues, multi-drug resistant bacteria, and how we can use natural compounds to fight at least some of the problems they are causing from a One Health perspective. So next slide, please. So antibiotic discovery clearly revolutionized medical practice. So we have reduced mortality, it's crucial in surgeries and on and on. But the improper use of antimicrobials led to significant ecological problems. The overuse and misuse in human and veterinary medicine led to these ecological problems, and we have an unregulated use in agriculture, and especially in the Asian countries in aquaculture. So antibiotic residues somehow entered the environment. You can see this on this picture there. This is a circle of contamination, be it from animal husbandry or hospital wastewater or communal wastewater, or also from pharmaceutical industry. So these antibiotic residues can be released through excretion via feces. They can be released via improper disposal of used antibiotics. And now they are present in wastewater, in surface water, and also in soil. Next slide, please. So this has a big impact on different ecosystems. So there's, of course, first of all, the problem that we might lose sensitive bacterial species, which then will result in a disruption of microbial communities. And this might also lead to a loss of key functional groups in ecosystems. So we have reduced ecological functions, likely like altered nitrogen and carbon cycles, and an impaired decomposition and nutrient recycling. So this could have then negative effects on plant growth and soil fertility. So when you have a look at this picture shown on the right, you can see that antimicrobial residues, of course, will have impact on antimicrobial resistance, but also on the soil microbiome in itself. The whole soil microbiome will be somehow interfered by antimicrobial residues. And of course, in the end, this will lead to changes in biodiversity. And of course, we will have an increase in antibiotic-resistant bacteria. And the interesting thing is this will not only happen with inhibitory concentrations, but also with low sub-inhibitory concentrations. We will have impacts on the ecosystems. Next slide, please. So there has been a lot of different papers on antimicrobial residues from animal husbandry, from wastewater treatment plants, and so on. But also the pharmaceutical industry contributes to antibiotic pollution. So we have discharge of antibiotics from manufacturing plants. We have high antibiotic concentrations near production facilities, and we have a lack of adequate treatment and regulation, especially in the southern part of the globe. So recent studies have highlighted that there is a significant contamination. And there were some examples where ciprofloxacin concentrations exceeded the limits that are given by 11,000%. So there was recently a study on ecological sustainability of antimicrobials. This was a pilot study by a health insurance company in Germany together with the German Environment Agency. And these results were quite shocking because they looked at different sites in Europe, also in India, and compared the concentration they measured to the so-called PNEC concentrations, so predicted no effect concentrations. And you can see this on the next slide, please. So what you see here in these green bars is the maximal concentration in industrial effluent, and in lighter green, the maximum concentration in environmental samples taken around pharmaceutical plants. And you see in red the PNEC, this is the predicted no effect concentration. This is the concentration where scientists believe that this concentration of antibiotic will have no effect on the soil microbiota. To be honest, I don't believe in this PNEC, but anyway, it's a value that can be used. And there you see that in some of the samples, on almost all of the samples, the maximum concentration measured exceeded the PNEC by far. So also here is a problem of discharge of antimicrobial residues into the environment. Next slide, please. So besides antimicrobial residues, there is also the problem of the spread of resistant bacteria. So resistant bacteria can spread to waterways, to soil, to food chain, and humans and animals, of course, contribute to the spread. We have an excretion of resistant bacteria into the environment by human and animal feces. And there has been several papers on the role of livestock and recently also on the role of wildlife in spreading resistance. So one big problem is the use of untreated wastewater for irrigation of fields, because via this route there is a risk of contaminating crops with resistant bacteria. And resistance has been detected in various environmental reservoirs. And with the parallel presence of antimicrobial residues, of course, this is some kind of interaction that might increase the occurrence of antimicrobial resistant bacteria. Next slide, please. So I want to give you an example because we wanted to know in the study, is it necessary to have an antimicrobial selection pressure and to have antimicrobial residues present that they are also antimicrobial resistant bacteria present in a certain area. So this study was published last year. And for the study, we tested several water bodies around Greifswald. We tested beaches. We tested also a river. We tested the effluent of the University of Medicine. And we looked for antimicrobial resistant strains, and we looked for antimicrobial residues. And the results are given in the next slide. Next slide, please. So what you can see here on the left, please back. What you can see here on the left is a phylogenetic tree, and I don't want to go into details, but in this phylogenetic tree, you can see that several multi-resistant global lineages were present at beaches where people go in summer. They were present there for over half a year, and these multi-resistant clones were present in surface water, so there is a risk of affecting people. And we also looked for antimicrobial residues, and the interesting thing was that there were residues, but the concentrations were very, very low. So it seems, and other studies are pointing to this direction as well, that multi-resistant strains survive in the environment even without the presence of antimicrobial selection pressure, which is even worse. So the question remains, is this somehow problematic? Are these strains just there in the environment and do not cause any harm? So one hint to solve this question could be found on the next slide, please. Next slide, please. What you see here is again a phylogenetic tree. This is a study we did 10 years ago in Berlin. Where we tested several cloacal samples from birds. We tested dog feces we found on the sidewalks in Berlin. This was the easiest part. We also tested human clinical isolates and dog clinical isolates. And we looked for a certain clone that is known to be spreading in one health context, a multi-resistant clone ST410. And the interesting thing was that we found almost identical clones of this pathogenic lineage in wild birds, in dog feces, in human clinical isolates, and in dog clinical isolates. So there is likely transmission, and the same clones can appear in humans, in animals, and also in the environment. So this is a public health problem. So next slide, please. So we have significant risk from antibiotics, so antibiotic residues and resistant bacteria in the environment. There can be exposure through contaminated water, food, or direct contact. And you all know infections with resistant bacteria are harder to threat. So we have increased hospital stays, mortality rates, and healthcare costs. So the economic burden is really big. And then as an example, we have around 30,000 deaths annually in the European Union due to resistance. So next slide, please. So what could be measures to reduce antibiotic residues and also to reduce antibiotic resistance? Of course, we need monitoring of antibiotic concentrations in soils, in groundwater, in wastewater. We need to improve wastewater treatment to get rid of antimicrobial residues and also of antimicrobial resistant bacteria. Ozonation could be one thing to do. And of course, we need to promote interdisciplinary research. And another approach, what we are doing here in Greifswald, since I moved my lab here, is we want to find alternatives to antibiotics. So next slide, please. And one strategy could be to develop virulence blocker. So we want to disarm certain pathogens by inhibiting disease-causing properties. So we want to have specific compounds with specific actions on pathogenic bacteria. So they can be used as an alternative to antibiotics for non-life-threatening infections or for prophylaxis. So one thing that we are currently working on is biofilm formation. You see here in the slide, planktonic bacteria can attach to surfaces, then they form biofilms, form some kind of microcolonies. And of course, these microcolonies, they are somehow protected against antibiotics because these colonies form strong bonds. And up to 70% of all infections, especially respiratory and urinary tract infections, are linked to biofilms. So biofilms are very interesting targets. Next slide, please. So in this study, also again, phylogenetic tree, in this study, we found something interesting. These are isolates from all over the world, from different resources, and from humans, from animals. And this is another pandemic lineage, ST648. Next slide, please. And when we had a look at this lineage, what we found was when pathogenic E. coli take up the ESBL plasmid, they not only become multi-resistant and can inactivate beta-lactams, they also start to produce curly and cellulose and produce these biofilms. So that's why it might be a good idea to tackle this multi-resistant bacteria by tackling their biofilm production. Next slide, please. So when I moved from Berlin to Greifswald, we started to screen different compounds for their anti-biofilm activity. And what you see here on this plate is biofilm production. You see these big red colonies. And on the left side, you see one small colony, whitish colony. This is an E. coli strain not producing any biofilm. So you can see the clear phenotypic difference. Next slide, please. And one of the plants we were looking at is sandu. So sandu is a carnivorous plant, Drosera intermedia or Drosera rotundifolia. It occurs worldwide with over 200 species and has been used in Europe as medical plant for centuries, especially for respiratory diseases. But with the training of the boglands, it had come under nature conservation rules. So for several years, it was not possible to get your hands on Drosera to do scientific work on the actions of Drosera species. So, but there are several programs right now in the European Union with the rewetting of the boglands, and now we have the possibility to plant Drosera on these rewetted peatlands and can do some research on them. Next slide, please. So we did several projects funded by the German Research Foundation, for instance, or the Federal Ministry for Research. We did some plantation experiments, some screening experiments for the activity. We did analytics, which compounds are in there and responsible for the activity. And we also did some first dosage form studies to figure out whether we have any interaction of a compound with basic materials. So next slide, please. And because of the lack of time, there's only one thing I want to present to you. This is the work we've done to figure out how the compound is actually interfering with the biofilm production in E. coli. So what you see on the right is, on the one side, you see a biofilm forming E. coli, non-treated, and on the right side, you see the treated E. coli biofilm with our sandu extract. So then we did proteomics and checked which pathways are somehow interfered by our compounds. Next slide, please. And this is just one pathway we found. It seems that our compounds, galloyl hyperoside, is somehow interfering with iron uptake and cytorophore production in E. coli. And this is interesting because cytorophore production is linked to biofilm formation. So it seems that we have a compound that is able to interfere with cytorophore production, thereby inhibiting biofilm formation. Next slide, please. And on my last slide, I want to show you something which is, I think, it's also very interesting. We are also using machine learning methods to detect new natural compounds and screen for their activity. So it's quite hard to get your hands on different natural compounds because they're expensive. They're just somewhere in digital archives where you can get the digital structure of the compound, but not the actual compound. So what we did was we did develop a prediction model for biofilm inhibitors. So we screened 300 compounds in the wet lab, took the data into a machine learning model, did some routes of prediction, and then let the AI decide from 4,000 digital compounds, which of them might also be biofilm inhibitors in E. coli. And the interesting thing is, you can see on the right, when we do the wet lab testing, we have a hit rate of about 4%. When we do some kind of pre-prediction with the AI model, we get hit rates up to 30 to 40%. So this is a more sustainable way to concentrate on the most likely compounds that might also be active against biofilm formation. So next slide, please. So in summary, so antibiotic residues are widespread in the environment, and also antibiotic-resistant bacteria are increasingly found in the environment, and we have ecological consequences. They are not fully clear yet. So antimicrobial residues and antimicrobial resistant bacteria are a prime example for the One Health challenge. And a healthy environment is essential for human and animal health. So natural compounds may offer solutions for some specific indications. And we believe that traditional medical plants should be scientifically validated to figure out which compounds are responsible for the activity and should be further developed. And yeah, new natural substances can be screened by using artificial intelligence. So I think I'm in the end of my 15 minutes, and I'm happy to take your questions.
Any questions in Leverkusen first, Olaf?
Thank you. Any questions locally already now? Not yet.
Okay.
I could shortly mention one. Of course, we are really also using cough and cold products which make the use of antibiotics in usual ordinary cough redundant. I suppose this is a good approach to really work towards less antibiotics resistance, right?
Yeah, you're totally right. I think for the non-severe, non-life-threatening infections, we must somehow avoid the use of antibiotics to save them for the life-threatening infections. So respiratory tract infections or urinary tract infections that not have reached the kidney can be treated with traditional medical plants. And therefore, we should avoid to use antibiotics. And I think in a recent scheme for doctors, they have made their way. So now we have, besides the antibiotics, we also have medical or phytopharmaceuticals which can be used in this kind of diseases.
Thanks. Back to Chesterfield.
Of some of the phytopharmaceuticals that are used in that. Can you give an example of some of the phytopharmaceuticals that are used successfully in treating respiratory infections and urinary tract infections?
So for urinary tract infections, it's I think it's from one of your competitors, angocin, which is used here, and it's within the guidelines. And for respiratory tract infections, everything from Hedera species is also within the guidelines.
Undergone clinical trials to demonstrate efficacy?
Yes, for angocin, there has been several clinical trials. Otherwise, it wouldn't make to the guidelines.
Go ahead, Mike. I'll get you the microphone.
Yeah, so maybe I missed this, but you have this example of inhibiting siderophore production, I believe, to prevent biofilm formation. That will end up leading to the same sort of threat of resistance, I would think. I mean, you could switch out antibiotics, but ultimately, I guess I'm wondering, is there something unique about this approach, the phytochemical approach, that will prevent resistance from forming again. Basically, you're going to be making them in large scales and have wastewaters having the same problems as well. So I guess I'm wondering, is it simply a new mode of action, or is there something special about this particular approach that will kind of prevent this cycle?
Of course, there will be some kind of resistance, but there is one huge difference when you're just disarming the pathogen compared to killing it. The selection pressure is much lower because the bacteria won't necessarily die. You're just making it unable to adhere to a surface to form a biofilm. So it's believed that the resistance development will be much slower compared to bactericidal or bacteriostatic substances.
Go ahead.
To add to that conversation a little bit, I mean, 80% of the antibiotics are used in animal husbandry. And in Asia now, far and away, they're not using antibiotics in animal husbandry. They're using essential oils. Oregano oil in particular is just as effective as tetracycline or whatever the other drug is. So there's probably a lot of other options out there for how we use a lot of how we use a lot of antibiotic compounds in animal husbandry.
Excellent.
Yeah, I think this depends on the kind of the disease. There are a lot of diseases that you can treat, for instance, with essential oils, but nothing systemically. If you have wound infections or something like that, essential oils will work as well as antibiotics. The thing is we need to reduce the amount of antibiotics in animal husbandry. In Germany, there has been a reduction over the last 8 years of, I think, about 800 tons a year. But I don't know the actual numbers in Asia or in other countries. So we need to reduce the use of antibiotics, and also maybe essential oils and other phytopharmaceuticals can be also used for certain diseases in this field as well in veterinary medicine.
There are 2 more questions online. Does anybody have a question in Leverkusen before we go to the ones online?
Not at the moment.
Okay. The first one is, there's a big push to use mitigated wastewater in agriculture instead of fertilizer. Should we be reconsidering this practice given the presence of antibiotics and things like hormones, like birth control and endocrine disruption?
So if we are using wastewater, we have to find a way to get rid of any antimicrobial residues, other medical residues, and of course of resistant bacteria. So this is a big problem, how to somehow sterilize that. And just using for mitigation wastewater, I don't think it's a good idea without any kind of sanitation or ozonization or stuff like that to get rid of residues and rid of resistant bacteria.
And many of the antibiotics used in livestock farming in the United States are not used in human health. Do you think this could take some of the pressure off of the evolution of resistance? Could it be used in a integrated pest management kind of style?
Yeah, the thing is, in animal husbandry, there are only a few compounds which are completely different from them used in human medicine. And even if the compounds have other names or derivatives of some core structure, the resistance mechanism might be the same. So even if you use a certain derivative of a tetracycline only in veterinary medicine, the resistance mechanism is quite the same. So I don't think, because I don't know for sure in the United States, but in Europe, most of the more or less bigger groups of antimicrobial compounds are exactly the same in human and veterinary medicine. There are only a few exceptions.
Okay. Anybody else have questions? Well, that's it from Chesterfield. How about in Leverkusen?
Thank you. I think we can proceed to the next lecture.
Okie doke. And Mark Maneri is here today. He's one of my mentors from WashU. So,
well, thank you very much for inviting me. And I'm going to take the opportunity here for us to talk about something futuristic, which I think is a huge opportunity. And it's the future of processed food. So, next slide. By way of introduction, I'm a pediatrician. I've been living in sub-Saharan Africa the better part of 40 years now. I'm a very old person, and working on developing new foods for food aid products, and had some tremendous successes we'll allude to. But, you know, if we think about, you know, a bad word these days, it's processed foods, ultra-processed foods, eat light Lancet diet says, you know, and the reason is shown on these bar graphs here, which just is an association of chronic diseases like hypertension, obesity, diabetes, and so forth with consumption of ultra-processed foods. And so, you know, the recommendation comes out that you shouldn't be eating these things. However, there are probably also associations between ultra-processed foods and longer life and other things like that. I mean, these associations are not sort of substantial objections. But when we talk about a processed food, what we're talking about is adding something to it. And actually, these days, it's not very creative. What we do is we add sugar because it tastes better. We add emulsifiers because it varies the texture. Sometimes we add salt or things for food safety reasons, these kind of things. And these then are consumed as a composite. All right, next slide. Let's try that. But, you know, the perfect, most amazing food that I want to talk about here most of this time is mammal milk. And in a sense, you know, it's a processed food because everything about it, which we're going to go through in perhaps a little more painstaking detail than you might want to know, but is functional as well as nutritional, okay? So the, you know, mammal milk is created over a period of 160 million years of evolution. It's a pretty interesting process of trial and error. And when something works, then it's kept. And when something doesn't work, it just fades off the radar screen. And so the dynamics of the creation of mammal milk, if you will, is seems slow, nothing's really happening, and then something happens, and then it seems quite quick. The kinds of things that are in mammal milk we'll go through several of them that are just totally amazing. There's thousands of compounds, and it involves probably 500 or so genes, or maybe 150 different genes to create mammal milk. The whole process accounts for about 5% of the human physiology. Very, very, very involved. And so what I'm imagining is we can look ahead to processed foods that take advantage of some of these same kind of things that we see that already work in mammal milk, and how we get that in there. And one of the motives for that, as a person who's been working in low-income areas for a while, is in order to get enough food to survive, you need about $2.15 worth a person. But in order to get enough food to give a completely nutritionally balanced diet, you need like $11 or something per person per day. And so it's substantially more. The $11 doesn't affect many of us here in this room at all. But for hundreds of millions of people in sub-Saharan Africa, this is a big difference. This is something they don't really have access to. So the things in the green bars on the right are just different properties. And unfortunately, I don't see them from up here, so I might be able to go out here a little bit if that bothers your camera, though. So let's go through some of these totally amazing processes that were used to create mammal milk. Next slide. So this is a picture that shows you that that mammal milk is not the same every time the child latches on the breast. From the time that they've just fed before, there's a little bit of backwash, which the mother is measuring cytokines and microbes and different indicators of inflammation and infection, and she's tailoring the next feeding to be better to meet inflammation if she tests it. And the red bars are showing you some common anti-inflammatory compounds that are in breast milk, like lactoferrin and lysozyme and different immunoglobulins, and how in the next feeding, when the child has an infection, that these immune mediators are showing up in the child's saliva, then the breast milk is different and presumably better. Next slide. Immunoactive compounds like lactoferrin. Somebody else was just mentioning iron. I mean, one thing to know about iron is we seem to see in human biology that this is the nutrient that when you want to control infection, it's what you go after. We have relatively large reserves of iron as people. We don't need to consume iron every day. And so whenever there's a hint that there's an infection going on, we clamp down with hormones inside us to stop iron absorption, and lactoferrin does this in the breast milk. Next slide. Supporting growth, there's growth factors, proteins that are, 30 or 40 amino acids or so. Epithelial growth factor, or IGF-2 is another one you might know about. In the breast milk, whole form proteins, and they have receptors that they interact with in the upper GI tract of the human, and they tell the body, get ready to grow, use these nutrients, we need to develop brain, gut, and so forth. Next slide. Just a review here, everyone knows this, but let's say it anyway. How the gastrointestinal tract actually works. So the cartoon on what's on your right has got, the mouth. We're crushing, breaking the food up physically, dropping it into a high acid environment in the stomach, which basically kills all microbes and denaturizes viruses. And then it moves right into the upper small intestine, which is essentially a pretty sterile place too. But it's basic. It's a pH of 8.5 or 9. And their enzymes are specifically cutting different chains of macromolecules in food, and very specific transporters are then taking up those nutrients. And that's probably 80% or so of our digestion and absorption. And then the body turns it over to another place in the small intestine called the ileum, where there's more microbes than any other place in the intestine. And this is, it says, here's what we've done, what we know how to do with it, break it down further, make me some vitamins and so forth. And that's what the ileum does. And then the colon is really a place where food hardly interacts with the human, the body itself. Unfortunately, we don't have a way to see or readily monitor what's going on in the ileum. Stool samples don't work because they're really from the colon. They're from a very different place after a lot of other things have gone on with them. So we know that it's something very important. We know some of the bacteria that are going on there, but that's about as far as we know at this point. Next slide. Breast milk, most of our diets are these disaccharides in terms of sugars. But they have these trisaccharides in breast milk, these oligosaccharides, which our bodies don't know how to digest, but these bacteria in the ileum do. And in fact, there's a certain kind of bacterium, Bifidobacterium longum, which is in infants, subspecies infantis. And so this is a way of targeting growth of this organism in the ileum. And then what this does is, if you're growing one thing, you're crowding out some other things. But it's also, the Bifidobacterium makes several other compounds to control other microbes and control enteropathy, from gut inflammation on the surface. Next slide. Hormones in milk, we have a lot of them: cortisol, insulin, thyroid hormones. Next slide. Natural antimicrobials. These are proteins like defensins that basically punch holes in the cell membranes of microbes, or block certain kinds of essential microbial processes. So these are just sort of ready-made antibiotics in the breast milk. And next slide. And then gene regulation is also an amazing thing. This happens through microRNAs, which are sort of 19 to 25 base pieces, which exactly match over a gene and will turn it off. I met microRNAs probably 25 years ago when we were trying to block aflatoxin synthesis in plants. They were called RNAis. They're called microRNAs. They're in an exome. These exomes are in mammal milk. In fact, I've even tried to administer things through exomes to people because you can extract them from milk in a fairly easy process. They're safe, and this is how the mother's milk turns on or off certain genes. It's usually turning off, really. And then next slide. So a little bit about what I've done and a little bit about my notion for the future, but embracing all that processed food, mammal milk is, can't we imagine that we're going to have a lot better foods in 10 years, in 30 years, in 50 years? And that's going to be one of the keys of how we're going to better feed our planet. Now, I, about 25 years ago, developed a processed food for severe malnutrition. And it was great. It was a game changer. It wasn't that creative. It involves peanut butter, mixing peanut butter, milk powder, sugar, and oil, and micronutrients, okay? And it was all designed on the food safety bit, right? Because I didn't want to be giving kids salmonella, and I didn't want to be giving them microbes. So I picked something that was very low water content. And now we have severe malnutrition, which has been going down year by year by year due to increased prosperity and diet improvements. And about 40 million children have received this. It was widely endorsed about 5 years after we developed it by all the UN agencies and all the authorities as the best way to treat malnutrition. The treatment can then be at home. Previously, it was in a hospital. And certainly it's accounted for 20 million lives saved of the 40 million children who've had it over the last decade and two. Next slide. So what I see in a bit of a looking ahead is the future of processed foods is untapped. You know, we can't really just, give something a bad name and then ignore it. I mean, that they say the essence of being human is we have the ability to imagine the future or imagine, not fantasy, but, imagine things that aren't in front of us. But we also better have the ability to discern what works and what's rational and what doesn't, and what really results in benefits. So I see us being able to incorporate functional components to enhance human health, to bring down that gap between the micronutrients and the macronutrients, what I mentioned in cost. And also on the climate side, we can create less waste, greenhouse gases. And foods can be developed specifically targeted to life cycle. So next slide, I don't think I have any more, but so yeah, to say thank you to that and to think about as organizations and as individuals too, how we can utilize that processed food in our futures to make our world a better place.
Thank you. Any questions? There's a question over there.
Thank you. Very nice talk. Is it? Okay. So with all these nutrients in there, but all those processed food will still be somehow make these, bisphenol A, bisphenol S, that sort of, things end up in the processed food, which might work as like endocrine disruptors. Exposure to those in early childhood might, still impact the gut microbiome and controlling the future health, outcome. So how to ensure those kind of, endocrine disruptors are kind of, cleaned out, or how do you make sure that those are not getting to the dose where they should not be? It's a big problem, right? Do I convey the question correctly, or? Yeah,
I think. I mean, maybe we can talk more at the end. I think it feels to me like less of a problem than there is, than it is. It's not. I mean, we are evolved. We exist taking in a combination of plants and animals and lots of dirt and lots of other things that we don't use at all, and sorting out, using the gut as a place to sort out what we're going to throw out. So I don't think it's something where we have to be highly, highly careful. I mean, if you're thinking about, like, say, phytochemicals in soy, okay, where there's thousands of times more of a certain kind of hormone, then we use science, right? That's why we have FDAs and regulation of what's safe and good food.
Thanks for the talk. So, quick question. What do you see as the link between food waste and regions of the world where there's overproduction, and how that can be converted into processed foods that are then shipped to places that are not producing enough? Is that a possibility? Is that something that,
I don't see that as so first of all, 23% of the greenhouse gases related to our food systems is from food waste, but primarily this is food that's prepared that we just don't eat. So I'm not thinking that we have a system where we prepare food someplace and then move it over to someplace else. I'm seeing that with processed foods, okay, let's say you need to put 6 things together on the evening dot table to get all the complement of nutrients, right? But if you use a processed food that may have combinations of things, maybe you only need to put 2 things together, and there's going to be less waste in those ways.
There's a question in Leverkusen.
First of all, I have to object the idea that bisphenol A or anything is an endocrine disruptor. That is utterly nonsense. If you look at the structure, it's so far away from any steroid hormones, and there are so many plant-based steroid-like structures that are far closer to anybody trained in looking at molecular modeling and structures. This is a distraction argument by activists that's causing a lot of trouble for Bayer, or has caused in our macrolome production. It's utterly nonsense. But having said that, sorry about the rant. Having said that, I actually wanted to, again, say something more than ask. I teach my children that there's no unhealthy food, there's only unhealthy nutrition. If you are undernourished, chocolate is probably a great food, and peanut butter so. If you're obese, it's not. And I think life, it's a lot simpler than what a lot of people want to hear. Of course, it's very healthy to eat fresh food if you can afford that, and it should be a substantial part of your diet. But if you don't have access to it, use the best processed foods you can get. Or is there anything wrong with that approach?
No, I mean, we didn't see vitamin A deficiency go away in Europe and North America until maybe 1920, when we started putting vitamin A in butter and margarine. And so, that's a role of another form of food processing.
Yep. Were you concerned about peanut allergy when developing your product?
I'm not. I haven't seen much peanut allergy. In our first 50,000 children that we took care of, we saw 5 or 6 kids with a rash, an eczematous rash. Now, to get at that, though, Liza, is that food allergy is learned. Okay, when a person is born, they don't know what they're putting in their mouth, whether it's food or germ, and so they say, we're going to say if we see something in large quantities or often, then we're going to call that a food, and we're not going to make an immunological reaction against it. If we see something very infrequently or in very small quantities, we're going to call that a germ, and then we're going to make antibodies and make an allergic reaction. And so the way to create food allergy is basically, and this happens in the first 10 months of life. It doesn't happen all the way going on and on and on when you're 30 or something. And so the way to create food allergy is to feed your child a very restricted diet the first year of life. And then you've created, the opportunity for food allergy. So peanut allergy is is a man-made problem. We're getting rid of it here in North America. I've got 2 kids that live with me, 2 grandkids, and that at grade school. And within the last 2 years, now peanuts are wide open at school. They're not prohibited anymore. So no,
Fascinating.
Feed your kids differently, and you won't have food allergy.
There's one more question online, but does anybody else have? There's a question over there.
No. Sorry to take the second question. You mentioned about bifidobacterium, and answer from Germany was also about like its food is more about, you know, something could be good for you, the same thing could not maybe bad for the other person. So there is a lot of research regarding soy food, where it has shown that the Asian population can get a better health impact of it because of their microbiome, which doesn't apply to Western population. So is there a need of like putting the right probiotics in the, you know, these processed foods, so actually you are helping them to, you know, convert to the right ingredients so it helps the health?
I would say that there's no evidence to date that probiotics are helpful. So I don't find any drawing or reason to be putting bacteria into food. Prebiotics, we could imagine some of these complex trisaccharides in younger kids, but that's an industry thing.
Mm-hmm.
Probiotics. All right.
One last question. What foods compose the $11 day optimal diet?
So, I mean, we're talking about 30 or so different micronutrients, and we're balancing how you could get enough of each of these micronutrients in the diet. Those have been codified a bit, trying to call it dietary diversity scores, although those are kind of circular sometimes because they say like vitamin-rich foods. Vitamin A-rich foods is one category we'll find, and those are orange foods and so forth. But it's not a 11 foods or 6 foods or something that I say you need to get the whole thing. It's going to be dependent on local situations, and some very harsh, some austere places may be hard to have that, to find that.
Okay.
But there's a really powerful tool that World Food Program has created for local diets. So you just go through and you say, this is what's available, check, 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 check. 200 items. What do I need? What does an average human, an average pregnant woman, an average 5-year-old, need to consume in a day?
That's fascinating. Thank you very much. Oh, wait, one more question. Sorry.
I wanted to ask about your slide that has a correlation between processed foods and the health effects such as obesity, et cetera, and ask your opinion about that correlation. If you think there's a causality, or what would your explanation be about that?
I would say that when we see correlations, whether between disease and health, diet in particular, I mean, I don't take that seriously, okay? I drove in the morning to come over here. If something happened to me, is it because I drove in the morning? No, it's just luck. I think that processed foods are consumed more in the developed world. In the higher income countries, there's a lot of things that go with that. I just view that as kind of traveling together. We're going to eat more processed foods, we're going to do more driving, we're going to have a bunch of other things, and we're going to get more of these chronic diseases.
Well, thank you very much. We are a little bit over time, so let's go ahead and move on with the next speaker.
Hello, everyone. Just checking if all good and I'm good to start.
Yes.
Oh, thank you. Super. So my name is Emma Shachurka, and I lead the medical access strategy within Bayer's Consumer Health Division. I hold a Doctor of Pharmacy degree, and I bring 20 years of experience in the pharmaceutical industry. My focus is on having an impact on access to health through self-care, which is critical pillar of health equity. If we move to the next slide, please. So today I'm really excited to introduce you our research. It's called RISE, which stands for Research Initiative for Self-Care Equity. RISE is a comprehensive review of over 400 studies. It's conducted across more than 50 countries and over the past 30 years, and in a wide range of economic contexts. It explores the impact of a number of socioeconomic factors on health, including lifestyle, demographics, environmental, and social influences. It looks across therapy areas where self-care solutions are commonly applied. These would include allergic diseases, upper respiratory infections, pain, women's intimate health, digestive disorders, nutritional deficiencies, and cardiovascular disease. Now, while we already know a lot about determinants of disease, this research takes a different angle on it. It focuses on how self-care can transform access to treatment, especially for vulnerable populations. So why is it important from a One Health perspective? It recognizes that health outcomes are shaped not just by the clinical care, but by broader social, economic, and ecological systems. And One Health is also about resilience. We all know that communities that are facing health disparities are often the most vulnerable to environmental shocks, infectious disease outbreaks, and chronic disease burdens. Our research shows that self-care can be a powerful tool to reduce this vulnerability, especially when tailored to the socioeconomic realities of the underserved populations. So if we move to the next slide, please. I would like to connect us back to our global mission, Health for All, Hunger for None, and our consumer health vision of helping 1 billion people to live healthier lives with trusted self-care solutions. There are a couple of words in these statements that are really what inspired us to do this research. Next slide. The first one is health. For low-income populations, self-care is often the first and sometimes the only option to manage many health conditions, yet it is overlooked by healthcare providers very often, also by policymakers and governments. Shifting the decision-making to individuals presents a unique opportunity to empower self-care, improve health outcomes, and enhance health system efficiency. However, to maximize impact and ensure equity, it is critical to parallel strengthen support mechanisms that mitigate socioeconomic disparities in order to care for vulnerabilities and not to put vulnerable populations at further disadvantage. The second one is trust. By investing in research policies, products, and digital tools that enable self-care, we can and must bridge the gap between access and outcomes, ensuring that vulnerable populations have the ability to manage their health with dignity and autonomy. This way, we will increase the trust by patients and consumers, our partners, healthcare professionals, and all other stakeholders. Next slide. Okay, so I would like to walk you through an example that illustrates the complexity and the connectivity between different determinants and how they impact health outcomes. So here we take cardiovascular disease as an example. Certain behaviors like smoking increase the risk of CVD, while others like regular physical activity would reduce it. These are what we call positive and negative associations. But health is also influenced by more than just behavior. And when we include other factors like education, income, and environment, we get a more complete picture. For instance, low income can lead to poor health outcomes, but it can also be the result of limited access to education. And we know that higher education often leads to better income opportunities. So by looking at these broader determinants of health, we can better understand the full context of someone's health and the barriers they may face. This also helps us to identify potential solutions from policy change to health education and relevant product development. Next slide. So in summary, low income increases the risk of poor health outcomes. The magnitude and the complexity of risk is increased when adjacent determinants are considered. So, for example, we have found that people with less formal education or those working in manual or blue-collar jobs tend to experience more pain, and not just more often, but more severely. And that pain doesn't just affect their health, it can mean missing work, losing income, and falling further behind financially. It becomes a cycle that is really hard to break, where health issues and economic challenges keep feeding into each other. And also let me highlight another example, which is close to my heart, and we found in our study. We have seen that women with lower levels of education are more likely to get vaginal infections. And if those stay untreated, they can lead to more serious issues like cervicitis, which can cause infertility in women who aren't pregnant or lead to premature birth during pregnancy. However, if we can detect and treat these infections early, especially during pregnancy, and especially in underserved communities, we have a real chance to improve health outcomes, not just for the women themselves, but for their children too. It's the kind of impact that can ripple across generations. And my last slide. Lastly, I'm really very proud to share with you that we have worked with Dr. Mike Reed, who is an associate professor at the University of California, San Francisco, and who have dedicated his passion towards health equity, especially focusing on HIV patients in sub-Saharan Africa. And with that, I would like to thank you for your attention, and I'm ready for any questions you might have.
Any questions in Leverkusen?
Not yet.
And any questions here before I go online? Can you explain how some of these roles are going to be, or this could be impacted by cuts in funding to global health programs?
Sorry, can you speak a little louder? It's difficult to hear.
Sure. There have been lots of cuts to global health programs recently, and are these programs at risk, or is there a benefit to public-private partnership in some capacity?
Yeah, so my opinion is that we really need to look for partnerships, and each player should take responsibility and how we collaborate and how we address these disparities. There is a lot that industry can do, but we cannot do everything alone. And partnerships with academia, with policymakers is critical in this space. So this is, I think, also the encouragement and the passion from Bayer we would like to encourage. So it's not just an internal focused, what we can do, but we look to influence how others approach this topic through our research.
Any other questions? Well, thank you very much.
Yes.
Go ahead, Olaf.
Short question. What you are presenting, Mise, is about supporting health of the billions by kind of supplements and so on, and OTC medications. And I think this could be a second stage after you've been fighting famine, as we have been shown that it can be done by feeding peanuts to children. And I think then a last step where Bayer is active would be then severe diseases, which would be coped by pharma-derived drugs. Could we see this as a stepwise approach towards more settled health state of the population?
Olaf, was that a question?
Yeah, it was.
So I definitely agree to. I more hear that as a statement from your side. Sorry if I didn't understand the question then.
Yeah. I thought we had just a lecture on how to fight famine in children, right?
Yeah.
And what you are telling about is rather if famine has been overcome, and then you would improve the health of the general population, right? By
Yes,
OTC
and you
medicines.
know, self-care is generally defined broader than OTC medicines, Olaf, right? It's we have a WHO definition which says that it is the ability to promote and maintain health, prevent disease, and to cope with illness and disability with or without the support of healthcare provider. So self-care is actually much broader, but it does include OTC medication, obviously. And, you know, one of the interesting things we also found is that the propensity to seek self-care is higher in the higher educated population. So usually lower income population would have lower propensity to seek self-care. So there is a lot that's needed from us and from different stakeholders to actually close that gap first, to enable people to be able to identify when they need to self-care and to diagnose if that's a self-treatable solution or not, and then to seek for self-care. So this is all included within the research we've been doing.
Oh, one other question in St. Louis.
Thanks. Yeah. So a comment here too. Half of malnutrition or poor nutrition is from not eating the right foods, and the other half has to do from having too much inflammation or inflammatory stimuli from your environment. And so the answer I would say to the person who just asked is yes. You know, yes is stepwise. We can imagine that there are things that can be in food that can not only provide nutrients but also reduce the inflammation or the substandard brain development, or the substandard linear growth, or whatnot.
Yeah, very good comment. Thank you.
Okay, and with that, we'll move on to our panel. So we will be starting with Kiliana Suzard.
Hi, Lisa. Hi, everyone. Can you hear me?
If you could speak up a little louder.
A little louder. You know, my voice is not very good today, but I hope you can hear me.
Yes.
Yes, so I will be presenting today a program called 100 Million Women Goal that has been established by Bayer in 2019. I do not work directly with this program, and I was quite surprised with how much I learned through preparing this presentation. For example, did you know that the United Nations says that about 200 million women in the world have no access to modern contraception, although they would like to use contraception? I mean, for me, it's a very, very huge number, and I was quite surprised. And I was very happy to learn what Bayer has been doing to address this problem as a goal. So I would like to go to the next slide. So maybe before starting here very shortly, my name is Kiliana Suzard-Wojcik. I'm an epidemiologist by training, and I work in the Bayer Pharmaceuticals. So I work in the past very closely with the team, work with neglected tropical diseases, but the first time that I have contact with the women's health. And I want to show you these ambitious sustainable targets that Bayer has set for the company, calling attention to the blue box, and we have the support for 100 million smallholder farmers. We also have access to everyday health, 400 million people with the consumer health, and also to provide 100 million women's health, women in low and middle income country to have access to modern contraception. I mean, this is a very serious issue at Bayer. As you see, even it has been included in the internal targets for Bayer. For example, 80% of the long-term incentive after 4 years, they are based on 80% of financial targets, but 20% in these targets, these environment and sustainable development goals. So that it will be influencing, as you see later, in how, for example, long-term incentive for management in the company is being rewarded. Next slide, please. So that's the important, interesting number. What is 100 million women goal? So the lead KPI is the number of women in low and middle income countries who have their need for modern contraception satisfied due to intervention supported by Bayer. And if you see in the first box, you see that about 86% of world population classify as a low and middle income country. In the middle box, you see initially, so when this program was initiated in 2019, the first year, Bayer could be able to provide modern contraception to 38 million women, then 41 million and 51 million. You cannot, I mean, if you see the small number on the box, is what was expected and was achieved on the top. Actually, so what was achieved on the box, as you see, as of 2023, Bayer was with 45 million women a year when the target was 51 million. I mean, in that year, the target was missed, but in 2024, Bayer was able to increase to 51 million women, and although it's still below the target that we would like to have, this 24 was 54 million, but it's really a big change. Something interesting, it's not a cumulative number of over the years. It means that every year Bayer is providing or putting these women into having the opportunity to use these contraceptives. So just what I said here about the performance, long-term performance of management, as you see, this is just to tell you that is really something serious at Bayer. So next slide, please. It's a little bit of a historical perspective. It's not something new. Since 1969, oral contraceptives has been supplied to US aid as a lower affordable price model. And also this program has been having continued extension. For example, with dedicated products to be supplied to United Nations, US aid, and other NGOs. And in this model of corporate social responsibility has kind of developed into something called the social business indeed. And which is quite interesting. And as you see on the bottom, you have the different types of contraceptives that are provided to such a program. So you have the implants, injectables, oral contraceptives, and hormonal intrauterine devices. And as you see, the program has changed from 2013 to 18 when they started putting Dejadel, which is the implants, into the program. And in 2021, Mirena has been added. Mirena is the last one, the intrauterine device. The next slide. But it's not all about giving the medication to the women. It is actually there are 4 strategies, and it is like two business strategies. The one is the commercial supply, will be the normal sales, in which women normally will be paying out of the pocket. So and this is for these 30 million women, 42% are coming from low middle income countries. And also there are other way direct sales. So these direct sales to countries that will be with a lower price, they will be providing to the population, but also through donor funded. So that from that ones for the about 26 million women are falling under this group. They are almost all coming from low and middle income countries. But like to call, it's not about only having the medication being available in the country and approved for use and also being offered in this training, in these programs, but also collaborate with partners. So that I would like to call attention to the TCI, the Challenge Initiative Partnership with the Bill and Melinda Gates Foundation, and also the University of Hopkins University, because they really they go in the direction that we discussed today, is about education, right? The TCI is a process to include the education about family planning and use of contraceptives, and Bayer is a very close partner. So that is quite interesting, because many women, as I understood, they don't use contraceptive due to lack of education, information, and the benefits of having the contraception. And another point very important is that has already started in 2017 is this digital support, in which is agnostic, because in that one, so it doesn't matter, it's not only for bioproducts, but also, I'm sorry, including education for younger populations to understand about sexual, how the sexual education, also contraception. The next slide. This is the part what I was very much curious in the beginning. How do you calculate 100 million women? And then you see, this is interesting because it's a motto called a couple of years of protection, something very new for me as an epidemiologist, but it describes the average duration of use. And this number is very widely accepted. So to say that the number of women using a medication we call in epidemiology the women years, right? So that we talk about 51 million women years, because we are here, for example, I need to calculate 15 package of oral contraceptive for each year, or 6 injections, or 1 IUD that will be like it's a long-term, long-acting contraception that will be working for an average 4.3 years, and implants also 3.8 years. Next slide, please. So in summary, Bayer is committed to enabling 100 million women in low middle-income countries to access modern contraception by 2030. This initiative addresses immediate contraceptive needs while contributing to sustainable development goals. One thing that caught my attention today was like these development goals that can be accessed by such a program. For example, the educational one, because women, when they are educated about family planning, they may wait and until they conclude their studies, so that before they initiate a family, so they will have less. I mean, they'll be able to control famine, because the family will be a little bit smaller. They will be able to through the knowledge and the contraception control how the family is going to be planned. And I was quite surprised that about 4 goals are only met with contraception. But that's very important is the partnership and investment in production sites that Bayer is doing, because of course we're using the distribution or increasing the distribution, but Bayer has been doing very much in terms of updating some plants in Finland and in Costa Rica. And this proactive approach aims to create an environment where women can thrive and make informed choice about their reproductive health. I would like to apologize a little bit. I was sick last week, so my voice is terrible. Thank you very much, and let me know if you have any questions.
We're going to talk about two other initiatives that Bayer's doing, and then Amis is going to say something as well, and then we will open up to questions after these two things, or these next two sections. So thank you very much, Kiliana. So I'm going to talk about two initiatives that Bayer's doing and that I think are really, really exciting, and hopefully we can partner with more academic folks and interdisciplinary folks on these projects. So the first one is, if we can put the slide up, the first one is the Nutrient Gap Initiative. And so 1 in 3 people in our world are surviving on diets lacking the essential vitamins and minerals needed to grow properly and live healthy lives and raise a healthy family. This is often called hidden hunger, and it is because of vitamin and mineral deficiencies, and they're especially prevalent in underserved communities, with women and children being the most vulnerable. This type of malnutrition, as Mark was pointing out, develops gradually over time, and the impact's often not seen until irreversible damage is done. Deprivation of essential vitamins and minerals may cause poor immunity, birth defects, reduced work capacity, and learning disabilities. Fragile health and failure to thrive are also exacerbating this cycle of poverty. This is why most micronutrients are part of the World Health Organization's essential list of medicines. As a global leader in human health and sustainable agriculture, Bayer is uniquely positioned to help people have access to proper nutrition, from food to safety net supplementation. Our goal is to impact 50 million people annually by 2030 by expanding access to diverse nutritious foods such as vegetables, fruits, grains, and nutritional supplements. Through intervention, education, and advocacy, Bayer is helping to close the nutrient gap in underserved areas around the world, creating a healthier community for generations. So some of the interventions that we're doing are: many underserved communities lack access to vitamins and minerals, either because they can't afford the nutrient-rich foods or supplements or can't find them nearby. So we're bringing nutritious foods and safety net supplementation, essential vitamins and minerals from the World Health Organization's essential medicine list, within physical and financial reach for those who need it most. In 2024, we reached 26 million individuals directly, including more than 13 million smallholder farmers with seeds and crop protection solutions, and 13 million more with affordable nutritional supplements. That includes providing 7 million pregnant women and their babies with multiple micronutrient supplementation in partnership with an organization called Vitamin Angels. We also have an education program that goes along with this. Many vulnerable populations lack the knowledge about proper nutrition, the importance of vitamins and minerals to their health, and how to integrate nutritious foods into their diets, and the value of supplementation when needed. Through both direct educational efforts and working with healthcare providers and farmers in a One Health way, we are striving to empower people with the information that they need to take their health into their own hands. In 2024, through a long-standing collaboration with technology enterprise Reach 52, we trained 150,000 people in India and Indonesia and Kenya, providing critical nutrition and self-care information to support improved productivity and health outcomes. Our knowledge transfer digital platform provides smallholder farmers with easy to access agronomic information to help them grow the most nutritious fruits and vegetables for their families and communities. As of 2024, these tools have the reach of these tools has surpassed 11 million smallholder farmers. We also continue to support Vitamin Angels to launch a continuing medical education curriculum in the United States, Mexico, and Indonesia. This is an accredited course which trains healthcare providers on the importance of this. And as of 2024, it's been completed by more than 300 professionals. And so that's just in a nutshell to the program that we've got with the Nutrient Gap Initiative. The other program that I want to talk about is the Safe Use Ambassador Program. As a toxicologist and somebody who's been very involved with global health and humanitarian work, this kind of program is very near and dear to my heart. What we're trying to do here is create a network that helps people have safe and sustainable farming. We're committed to providing the safe and responsible use of our products. This is part of our stewardship program. We believe that everyone can play a role in achieving this goal, which is why we launched the Safe Use Ambassador Program in 2017. The Safe Use Ambassador Program aims to advance farmer safety and reduce the impact of crop protection products on the environment through knowledge transfer and empowerment. Each year, over 1,000 Safe Use Ambassadors successfully complete our program and continue to pass it on to the acquired knowledge to thousands of farmers in their communities. Furthermore, the program enables us to strengthen our relationships and collaborate with local poison control centers, universities, and other stakeholders in the agricultural industry worldwide. The Bayer Safe Use Ambassador Program aims to advance farmer safety by training diverse stakeholders, such as agricultural and medical students, agronomists, and rural medical practitioners as safe use ambassadors. We partner with academia and health professionals to provide a tailored training on safe use related topics, as well as regular events and webinars on aspects related to the sustainable use of pesticide for our stakeholders. In partnership with universities, we train agricultural students on the safe and responsible use of crop protection products. In return, the Safe Use Ambassadors sow the seed of safety in their local communities by training similar thousands of smallholder farmers. So it's a knock-on effect, a little bit like the extension programs that have been so beneficial in the United States. Every year, we also reward the most dedicated student from every country with an all-inclusive trip to Bayer Crop Science headquarters in Mannheim, Germany, where they get to exchange with other ambassadors from the agricultural and medical sector. This is truly a One Health program, and they foster their knowledge of safe use. Furthermore, we collaborate with agricultural ministries and regulators for the sake of knowledge exchange and capacity building. In 2022, we extended our Safe Use Ambassador Program to the medical sector, offering customized training and access to information and materials on the prevention and treatment of agrochemical-related poisoning, snake bite, and heat stroke. Through the program, we equip medical students with vital knowledge on the treatment and prevention of crop protection product-related incidents. In turn, they apply this expertise during their future practice in rural communities. To recognize exceptional students, every year we offer an educational all-inclusive trip to Bayer Crop Science headquarters in Mannheim, which allows them to expand their networks by connecting with fellow ambassadors from both the medical and agricultural sectors, as well as Bayer scientists and global managers. However, training is not enough. To ensure the long-term reduction of incidents, we encourage our ambassadors to report any incidents related to the use of our crop protection products. Furthermore, through our partnership with poison control centers and rural doctors, we aim to expand our database and enhance the post-sale monitoring of our products on the market. This data should allow us to be able to better identify how we can improve our portfolio and service management, making our products safer every day. Last but not least, we plan to further extend the program by partnering with the Better Life Farming Network and assigning a trained medical provider to each Better Life farm for enhanced knowledge transfer. To support the healthcare needs of these communities, we will provide snake antivenom antidotes and other items such as dietary supplements, vitamins, and sunscreen. This has become very kind of successful over the past year. We have started to partner with an organization called the Consortium of New Sub-Saharan African Medical Schools, which is a consortium of 130 rural medical schools where we are providing education about the management of pesticide exposures and pesticide overdoses. And we're trying to develop a network of poison centers through those schools to enhance and harmonize poison reporting across those systems. And with that, I think maybe Amisi has something to say, and then we will take questions. Oh, okay. So that was Macy's presentation is what we'll ask questions for too. So final panel questions and answers about the programs that we have at Bayer, how we're committed to a One Health paradigm, and we're happy that you joined us today.
I hope you can hear me.
Yes, we can.
I'm wondering, given the dissolution of USAID, how Bayer is pivoting to be able to ensure that women still have access to contraceptives, given that that was a primary partner and a really significant distributor.
Kiliana?
Yeah, this is a very good question, and unfortunately I cannot yet, but I will reach out to my colleagues from the public affairs. I think it's a situation that is ongoing, right? I mean, I don't believe that's going to be affecting it now. But how it goes ahead, I'm not very sure. But for sure, as I said, these goals are like included in the Bayer's DNA. And since the company is very much committed to reach the 100 million, I'm quite sure they are looking for alternative ways. Since as shown here, the USA is really one of the strongest partners. But of course, the United Nations continue to be, and Bill Gates Foundation and so on.
And I can say the same thing for the Safe Use Ambassadors program and the CONSAMS program. I'm going to Kenya in September and for one of our meetings. And so we are trying to make sure that there's continuity, because we've committed also to 100 million smallholder farmers to have them have access to the best agronomic and best healthcare. So. Let's see. Here's another question. When checking the impact of sustainable production of medicinal plants for out-key natural over-the-counter products, we see the most impact on Sustainable Development Goal number 15, life on land, and then Sustainable Development Goal number 12, responsible production, then Sustainable Development Goal number 4, quality education. Do you see this sequence in general in agriculture too? And the next question is, how can we increase the impact of consumer health products to avoid environmental impact, and how to make the most of natural products on that way to billions? So yes, I do think that there's a lot of benefit to natural products, and it's interesting because we in the agriculture we've got a whole program where we're working on biologics and biologic management of pest control and things like that. Many of our products are also, in terms of crop protection products, are also based on Mother Nature. We talked a little bit about pyrethrins, which come from the chrysanthemum earlier, and we've modified that a little bit. The term synthetic often gets a lot of pushback from it, but synthetic doesn't always mean bad. This means just less allergenic and more light stable. And so Mother Nature kind of underlies what we want to do in agriculture. There's a lot of discussion about whether or not our products impact farmers' soil negatively. If you've got regenerative ag going, farmers are most in touch with their soil and they don't want to destroy it. And so we hope that our products, or we work to make sure that our products will be able to ensure healthy farming. And then in terms of increasing the impact of consumer health products to avoid environmental impact, how to make the most of natural products on that way to billions. I think that many of these natural products have a very low environmental footprint, but we had a question earlier about plants being grown in consumer health as supplements, and I think that there's a natural crossover there from ag and human health. It's sort of the group that has both components in it. So I think that it's important to look at those things that way. Kiliana, any thoughts? Or Macy, any thoughts?
No, thank you. I agree.
Okay.
And nothing to add from my side, thank you.
Any questions in Leverkusen or here in Chesterfield?
Hello.
All right.
Would you like to state something on One Health following this large-scale overview? feel free to reach out.
So I have a question which may not be related to your three talks now, but to something which was discussed earlier. That's the whole issue of natural products and medicinal plants, which I personally find extremely attractive, especially for low-income countries. We worked a lot on these issues when we looked for antiviral activity of plant extracts and so on. My question would be, I see some problems still with these things. The first thing is access to the natural resources, which is highly regulated. We have the Nagoya Protocol issues, and it's even a mess to work as a researcher with that stuff, because you cannot get access to plant extracts, so without having like tons of bureaucratic documents to fill. The other issue is that if you purify compounds out of a plant extracts, for example, that must not necessarily, they might have a function which you can test, but it may also be that several compounds in a plant extract work together to get the final activity. And here you have the question always open on patentability of plant extract, and also on the way how you will actually do the quality control. This may even be already a problem if you have plants growing in different areas of one region, that the constituents might be differing, and you do not really know how to control that always the same constituents are present there. So while I'm really very open to natural products, and I think this could be a solution of many things, there are a lot of legal problems with that, of strategic problems connected with that. And my question would be how Bayer would deal with that.
Well,
a big question.
Yeah, that's a great question. Olaf, you do a lot with Iberogast, so perhaps you could comment a little bit on that, because those are some of the discussions that come up.
Do you hear me?
Yes.
It's like this, that of course the research on natural products is sometimes challenging. And of course, as you mentioned, there is some variability of constituents of natural products and plant-derived mixtures of constituents, depending from, of course, the region where it is grown or the year and the weather. Still, we find in research that there is a kind of constant pharmacological effect, despite some varieties of some constituents, which is allowing to gain a reproducible pharmacological and therefore also therapeutic effect, which is shown for quite some of the products we are dealing with by quite a lot of placebo-controlled studies of different batches. So obviously, of course, there is a kind of homogeneity of the therapeutic effect achievable in natural products. This is one point I would like to raise. Of course, there is another point regarding, which you mentioned, regarding research. And you mentioned the excess benefit sharing. Indeed, this is at present, and I think there we are in common with especially also crop science colleagues. Excess benefit sharing can really a challenge for doing research for the better of mankind, given that the present approaches, which are officially binding, are often not supportive for research, and rather limiting research on natural products instead of supporting it. And of course, this is a challenge we are all struggling with and trying to really, of course, making that happen. What was intended by excess benefit sharing which means to have a equal distribution of benefit with the producers or owners of the plants, and of course with the users of the plant-derived products, which are our patients and consumers. And getting the right balance is, of course, not easy. This I would like to state on your first remark. Don't know what you would like me to go further into details of this.
The question of patentability, let's say. So how could you get protection? You can probably not protect the plant extract. And that was actually, to my own experience, a hindrance for a small producer who said, I cannot really protect that activity of my plant extract. So I do not have the money to do bigger clinical trials. Because I never, because you will always have the competitors in line then. If you have positive results from a clinical trial, then the competitors very fast with having the same product without spending all the money. So how is this legal issue handled here?
Yeah, to state, and I may be a colleague of mine can also state on this. First remark on this is, of course, the lack of patentability can be a challenge to really get the support, the financial support to develop a new product. But you are in consumer health anyway in the field where often patents are expired or not available at all. Just to mention aspirin or ibuprofen and so on, these active ingredients, respective products, are of course not protected by patent as some newly developed pharmaceutical products would be. So it's very much about building a brand which is really recognized by the patient and consumer, to really show the advantages of the product you have to the consumer, and of course consumer and even also healthcare professionals and thought leaders are then supporting the use of such a product which really can show a benefit as compared to products of competitors. This is just my view. And would you like also to state, Rami?
Thanks, Olaf. Just maybe two examples based on experience with two patents we have worked on them related to natural products or herbal medicine. Yeah, you are absolutely correct when it comes to the point that you cannot patent the herbal ingredient as such or per se, but it has to be linked to a specific benefit or a specific endpoint, meaning that plant X is effective in this disease, but to patent the plant per se, this will not work. And for the plant to be patented, you need also to the standardization behind the plan, meaning that it is standardized to XYZ by this percentage, and this percentage showed efficacy in these preclinical studies and then in the clinical studies. We have a successful patent with this approach somehow. The second one, it comes to synergistic combination. Sometimes you apply for patent and then you get challenged somehow that previous competitor or previous research group that they patent this plant for the same benefit space. The tweak that you could make around is related to adding additional herbal ingredient and prove the synergistic combination, either by reducing the dose of the first one or by reducing the side effect associated with if there is any side effect. So usually these are the two approaches, either standalone, link it to end benefit, or synergistic combination and showing the synergistic, because usually they ask for endpoint for this synergistic combination. Yeah. Thank you.
I have a question for consumer health. One of the common things that you hear are that consumer health products or supplements, and often the herbal remedies aren't regulated. Can you comment on that? Because that's a popular misconception.
To give a very short introducing statement, of course, regulation is a matter of nations or regions, and of course we have very diverse regulatory frameworks, for example, in the US, in Canada, in parts of South America, or in countries like Japan, China, and the European Union. And in each of these countries or regions, the framework is different. For example, in Europe, there is important an important part of the herbal products regulated as medicines, which is, of course, a relatively strict kind of regulatory surrounding, while in other parts of the world, the regulation is less stringent, and so also the quality of the products might be more variable. To give this as a short introduction, anybody to state on this on top? Yes,
I don't
Rami?
want to be like the advocate for consumer health, but maybe just few points to add on this. First, from regulatory perspective, as Olaf outlined, that there are different regulations based on the region. Here in Europe, for example, that you have the food supplement or the dietary supplement and the OTC. For the OTC one, by the way, you follow similar approach to the RX one. So you have to apply for CTD and you have to show the preclinical, clinical, and the quality and so on and so forth. So I would say for OTC, there is no way. You have to prove the science, and it has to be backed by a very robust science to be approved for the indication you applied for. For dietary supplement in Europe specifically, you have a list of claims based on the ingredient you would like to put in the market, and you cannot go outside these claims somehow in Europe for dietary supplement, meaning that all those claims are approved by the EFSA or the European Food Safety Association to show that these healthy claims somehow are related to the ingredient you are putting. Something like vitamin C contribute to strengthen your immunity. This is approved by EFSA, and there is science behind this. In other regions, yeah, there are also certain regulations. And if we are speaking about bears specifically, I believe you can check also all the science behind which is publicly available either for Iberogast or aspirin or any other brand. So scientific robustness and the regulation, I would say at least there should be science behind, because without the science and the substantiation, you will not be able to put the product in the market without any challenges from other competitors.
Thank you, Rami. Leah?
Yeah, I'm going to go back to the ambassador program that you talked about with helping the safety training in the field, and you focused on Africa, which is a great need, but I'm wondering if that program also covers other mid to low income regions, because there may be needs in LATAM or some of the areas that we also focus on.
Yes, as a matter of fact, we do cover India, and we're working on programs in South Asia at the moment. The Africa component, the Consims component, is the newest component of the program, but we have a very successful program in India, and then a very developing program in Southeast Asia. The Indian program is really interesting because it also has this snake bite program that's actually incorporated in the people who are growing our crops have access to anti-venom. And because if you think about it, if you're hand weeding the jungle, you're very prone to snake bite. And in 2017, the World Health Organization declared snake bite as one of the leading neglected causes of mortality and morbidity. And it's largely in young, healthy agricultural workers. And so they're trying to help fund programs for ameliorating that problem. And we've got a very successful snakebite program established in India, where our grower communities and their families and the villages that they live in have access to anti-venom. And we're trying to develop similar programs in other spots as well.
So I'm wondering that because Bayer's shifting its focus over the next 5 years, if that will affect what regions this program is in, or are we going to be able to maintain the focus of this effort independent of how Bayer shifts
Yes.
The business focus?
As far as I understand, this is one of their big priorities, and it's a part of the stewardship commitment that they have to the life cycle management of our crop protection products for the Safe Use Ambassador Program. So I think it's a very, very highly, it's one of their priorities. Yeah. Mark, do you have a question? No? Okay. Anybody else have a question in Leverkusen?
Crop science or pharma here with questions or statements? Just the auditory.
I don't have anything online. Maybe we can wind up with a few final comments. So thank you everybody for joining us. Oh, actually I have a question for my two panelists. What do you think is the most important global health challenge, One Health challenge that we're facing? And what suggestions would you make for improving that? Those are big questions. So we'll start with Dr. McLean.
I think you should start with Dr. Maneri. I'm going to dodge the question a little bit by saying, I mean, a global health challenge, and instead look at what impacts confidence in being able to advance research and be able to introduce, for example, new technologies or new treatments. And it was touched on a little bit earlier. And so I think really being very intentional about communications is such an important factor. And it's not, again, talking to, but also listening to, so that there is an iterative engagement with audiences. And that, as I said earlier, context is incredibly important. So there isn't one health. I don't mean One Health in the context of this talk, but a single global issue that I would point to, because there are so many issues that are impacting populations in so many different ways across different geographies, across different demographics, across different socioeconomic strata. And I think it's really important for us not to generalize and actually to take the time and put the resources in to truly understanding so that interventions are fit for purpose.
Excellent. Dr. Maneri?
Yeah, I would, I've always relied on what I consider my most powerful tool, which is a randomized double-blind clinical controlled trial. And plenty of ideas can be worth plenty of investigations, but I would say we need to build our lifestyle, I guess, based on evidence. And so I would put that out there, and that evidence is not, we've used in the past expert opinion and so forth, but we're in a world where as just before Maven mentioned that information is being manufactured, distorted. There's plenty of disinformation. We can't even tell advertising from information anymore.
Mm-hmm.
And so we need to restore that. I think that in terms of it's a hard question. Wish you would have told me beforehand. I would have thought of a better answer. But just having a perspective. What I was thinking about was a project that I was involved in Ethiopia, where people were raising chickens, and the chickens were doing something good for their nutrition and their health. But then the chickens were, to keep them safe, were also in the house, and they're staying up on the edge of the top of the ceiling there, and they're pooping, and the toddlers then are eating the chicken poop and getting Campylobacter. And so, you know, all of that picture needs to be taken into account. And it's really, you're going to see, do you see effectiveness? Do you see evidence in that, you know, with respect to that?
Excellent. Do any of our other panelists have any final comments?
Yeah, would you like to give a short message for us to take home? You both like to start?
Well, I tried to highlight in my talk how, you know, you can have scientific innovation, but to tackle complex issues, you know, as we are dealing, you know, with One Health issues, you know, it's important not to neglect the dimension of education, because without education, no, the science will not work. That was my only message. I'm a man with just one message, and that's the one. So that's my take home for you message.
So the question, what's the most urgent thing to do in terms of One Health? It's a big question. It probably you could give an answer of 1 hour length or so on.
Mm-hmm.
But for me, one very important issue is building trust. Building trust between people, and that includes everything. That includes education, that includes communication, that not only includes communication with of scientists with the industry, but also communication with the society outside in many different flavors, depending on where in the world you communicate. And I think if there is a certain amount of respect and trust between people, you can achieve a lot of things. So this, to me, is one very important issue.
Any other thoughts? Olaf?
Back to Chesterfield, I would say.
Okay, well, thank you for participating. We really enjoyed having you. It was a wonderful discussion, very interesting talks from the whole group of people. I hope we can build on this. I think really we, as a company, take the idea that health for all and hunger for none is very, very important. And we really believe in Sustainable Development Goal number 17, which is about partnership, and hope that we can continue having conversations like this to collaborate on very meaningful projects globally. So thank you for your time, and have a nice rest of your day.
Vielen Dank auch lokal.